certifications. I'm thrilled today to talk to you today about interactive network docs with Jupyter and Netmiko. This is a topic that's been kind of rattling around my brain for a couple of years, and I finally had the right inspiration to try to pull it together and share something, hopefully with you, that will benefit you in your network journey. Just at a high level, what we're going to cover today, first we're going to talk about what is the documentation challenge, what is the problem that we're trying to solve here, and then we're going to look at the nuts and bolts of those different technical solutions within Jupyter Notebooks and Netmiko, and then we'll move into an interactive docs in action with a live demo that you'll be able to then see exactly for yourself what it looks like, and then some practical use cases for yourself and things you can take home for your own edification. First off, who here has struggled with good documentation? Who here was the problem that it was not up to date? I can relate. So sometimes you yourself are the problem. And within documentation, one thing that comes to mind, I was in network operations in Cisco IT for several years in the campus and branch team. And we were fortunate enough to be a large enough organization where we had a separate team that implemented and put out those network devices, and a separate team that operated them. I was on the operations side, and so one of the jobs we had was doing a checklist to make sure all of those implementation details were correct. All of the ACLs, interfaces, all of the things that were being done as we were doing a fleet upgrade of refreshing these hardware devices, our team wanted to make sure that there'd be no operational issues down the line. And we had checklists and documentation from our side that was mostly just a hodgepodge of Excel spreadsheets and notes from individual engineers. And I wish I had something a little more interactive, something that could help me in an automated way talk to these network devices, get the actual data that I'd be talking with. Another thing that came to mind when I was thinking about what happens without good documentation is later on in my career, I was in a consulting role. And we were hired on to different organizations, and oftentimes it was because they had no documentation. They actually brought us in to help document their network, and then we were paid to then teach them about their own network. So this is something that is really near and dear to me, both in terms of my personal experience within the operations team, and then also later on helping other operations teams as well. And I hope you can relate to some of these quotes. Who changed the config last night? I don't know. What happened? So the documentation challenge, I want to frame that picture for you. We have three areas. Outdated documentation. You need to make sure that the information within what you're talking about is still kept up to date. And even if you are keeping it up to date, it can take a lot of time to gather that data from your network devices and get it into the right place. And then even once you have that information, being able to share that with other people so that everyone is all on the same page. So all of that needs a solution. And now focusing specifically on networking, why documentation matters in networking. On the right-hand side, I have the flow of what network engineers typically deal with, where you have the planning, architecture, designing what is going to go on your network, deployment, getting all of that out into the field, operations, once it's up and running, and making sure that you're able to keep it running, and then monitoring. And so I'm mapping each of those to areas in documentation that how it can help. So when you're planning, you need to be able to collaborate and understand what are your design standards, what are your IP address standards, what are your naming device standards, what are the different configuration standards that you need to have in place. Because if you don't have that in place, then it's going to be a whole bunch of mess once you actually get to deploying. And then when it comes to deployment, getting new people up to speed without good documentation is really a big struggle. I know within our team, we struggled a lot when we were dealing with contractors or with new hires, people who are just saying, your network is so big or so complex, how can I actually achieve the outcomes you're asking for without good documentation? And then once you get your network up and running, how can you troubleshoot it without actually knowing what should be on your network? And then finally, within compliance, you can have security compliance, you can have organizational compliance, you can have all kinds of different areas in which once you get up and monitoring, you need to be able to know what should be accomplished. So I built this XY axis to help visualize the different types of documentation, because I think when we think about docs, you just think of this big nebulous concept, and I wanted to break it down a little bit more before we go into some of the other details. That I think of docs as either organizational or personal, something that you're using just for yourself or something that you're sharing around with everyone else. or something that's static, it doesn't change very often, or something that is continuing to evolve. So on the static and personal side, we have configuration snippets, maybe a list of show commands that you keep locally on your laptop. That I would still consider documentation. It's something that you're using to reference in order to accomplish your daily work. And if you're not sharing with anybody else, then they're not benefiting from that as well. On the organizational and static side, so something that doesn't change very often, you have architectural design documents, possible PDFs or Visios, things that are telling your organization what you want to have on your network. And on the dynamic side, I'll just highlight Grafana dashboards, other areas where you're able to see the constant changes of what's going on in your network, but you're not actually touching the nuts and bolts, and there's not much documentation in terms of specifics. And finally, on the bottom right, Jupyter Notebooks, which is what we're going to talk about today, where I'm thinking of it more in the personal sense, where it's not something that you would share for your whole organization, but something that you personally would use in your different engineering tasks, but it's still dynamic. So think about this, a network engineer's worst nightmare. You're already overloaded on cases, and you're struggling to keep up with all of the demands of what you have to do. It's time for that security audit. Your manager asks you, where's the audit? I asked for this last week, and you're already behind. You scramble to collect those CLI inputs from dozens of devices, and you copy and paste it incorrectly, and you're trying to format it into the right format for what the analysts need. It's taking forever, and the deadline is now. I don't have time for this, you think. And I can definitely feel this pressure when I was in operations, that you already have all of your casework, and then you have people asking you on top of that to get the information needed for something that could be easily automated. What if we could do this automatically? What if instead of manually logging into multiple devices, you could retrieve that information automatically? What if instead of copying and pasting that data into Excel and extracting the values you want, you had a way to structure that data and automatically put it into a format that you could share with other people? What if instead of having static Word files, you could keep your documentation automatically up to date? Let's see how Jupyter Notebooks and Netmiko can make that happen. So Jupyter Notebooks give you dynamic and interactive documentation where you can automatically have your CLI collect data from the network and then store it in a place for you to then share with other people. And then it's in a format markdown that then you can publish and share with other people as well. So what are Jupyter Notebooks? Jupyter Notebooks are actually really frequently used in academic environments and for data scientists. So I actually saw this in a presentation from another network engineer named Jeremy Schulman, who did a great job of showing how Jupyter Notebooks in a network engineering environment can be a great way of combining both code and documentation in the same way that data scientists already use them today to share their reports and their PhD theses. They use it more for MATLAB and data plotting and things like that. But for us, for network engineers, we're doing something similar in the sense of that we're trying to both interact with data sets in the sense that we have network devices where data is, and then also providing a narrative around that data that then we can share with other people. So Jupyter Notebooks give us that platform that is a low barrier to entry. You think of a lot of data scientists, they're not as hardcore software engineers as anybody else, just like us. With the network engineering background, I know at least myself, when I started network engineering, it was because I didn't want to get into software engineering as much. I think data scientists are probably in a similar boat. And so Jupyter Notebooks give us a platform that's easily accessible for anybody to use. So some of the key features for Jupyter Notebooks is that they have interactive cells, that they have these little squares that you can type in with either Markdown or code, that as soon as you execute them, it renders either the output or the rendered HTML for your headers, your lists, tables, different things like that. Has Markdown integration, which then you can export to GitHub, GitLab, and other formats where Markdown's easily consumed. You have CLI tab completion, where as you're entering in your Python commands, if you forget exactly how that command finishes, you can have that tab completion be pulled in through the Jupyter Notebook interface. And then ease of sharing, you have export formats for both PDF, HTML, and Markdown. Because, like I said, one of the key parts of documentation is, if you're doing it for yourself, is not just for your own edification, but being able to share that with other people. So how are we actually talking to the network devices? So Jupyter Notebooks just hosts a Python kernel, basically an area for it to run the execution environment. And Netmiko is a free and open source library that connects to network devices for you. It handles the authentication, it handles gathering sending the commands, parsing it in order for you to get that data you need to be able to build the reports that you want. And it covers both iOS XE, XR, ASA, all other non-Cisco vendors as well. So really, it's a great platform, great library for you to be able to utilize to be able to talk to your network devices. How do you get started in terms of installing it? Well, first you need to have Python installed. If you have a Mac, it's already installed. With a PC, it's fairly straightforward as well. Once you have it set up, you want to create a working directory. In that working directory, you create a virtual environment. And the virtual environment, you just say pip install Jupyter Netmiko, and they're both free to use and quickly installed. So when you type the words Jupyter Notebook after it's installed, you can see here some renderings. Basically, it will spin up a local web server for your machine, and then it will render that on a web page for you to then interact with on your local device. You can also host them, obviously, on a server, but what I'm just talking about here is for your own kind of personal testing. And once you have that up and running, you can click New on Python 3 to create yourself a new notebook. And each of these Jupyter Notebook cells you can render with either Markdown or code. So let's move into the live demo so you can see exactly what I'm talking about. Let me get some water here first. Where I think my browser disappeared. That's not good. Let's open it again. Sorry. Let's see here. Oh, it's over there. That's why. Sorry. Okay, there we go. It just wasn't showing up on my local screen. So we'll just go on the side here. So what we have here is the Jupyter Notebooks interface. You can click around, and basically we have here the Markdown. So this is how you type it out, and the Markdown syntax, when you execute it, will then render. And then you can choose on the drop-down whether you're doing code or Markdown for the particular cells. So I just made that cell that was code into Markdown and back. And so now that we want to actually run the command, so we have your commentary, you have your code, and you can have more commentary. And then when you want to run your code, you hit Shift-Enter. In this case, of course, in your production environment, you would not want to have your credentials hard-coded, but this is just a sandbox environment. So we have importing Netmiko, we have our information, we have creating our network object, and then we're demonstrating here that you can actually prompt for user input using the Python prompt and have it plugged in. So we're going to plug in, enter a show command to run, and that command is going to be sent to the device. So we'll say show IPNet brief. And when I send that, it then sends it to a network device. I'm on a VPN and renders the output on the screen. So you can imagine if I was doing that series of network checks, you could have your all of that documentation on the Markdown part, or you could define your commands in your code snippets or ask users for input. You can also, another example of a code feature within Jupyter Notebooks I want to show is using the %% time magic command to measure execution time. So if I execute this cell, it will send it to the network device, get the data, plug it, and render it to the screen. And if I scroll down to the bottom of the show version output, it will tell us exactly how long it took to send to the network device. And we can see it took 518 milliseconds. And I can send the same command now using the text FSM parsing. That takes a little bit longer. But it takes all of that information from the show version and puts it into a structured data format that then we can plug into other values. And you can see it took a little bit longer, which makes sense because we're adding some parsing information on there. So I'm going to give one more brief example here, and then we'll go into a full workflow for a method and procedure. So you can also, within this Jupyter Notebook, we're usually referencing the data from the previous cell. So you'll notice that I'm not redefining my steps. So my first step, I defined my device. I created the object, and then as I'm going down the flow, I'm referencing those same objects. And so now at the bottom, I can, in the third step, just simply say, here's my list of show commands, and I want to print my results. And when I do that, it will send the list of show commands here of show IP interface brief, show version, show clock. It will put each one of those into a dictionary, and then render the output under the information. of the headers. So we have the show interface brief, show version, and show clock. So now let's take a look at a more, let's say, built-out use case where, let's say, you have probably something that's a little more explanatory than what I have here in your own examples, where you have your markdown explaining your method and procedure. You could define the device that you're talking about, and these could be changed by the users at any time. And then some config commands that are defined as variables. And so we're initializing that, we're setting those variables, and now we're taking those variables and plugging them into a new object. So we've actually created variables for a pre-output where we're going to capture that show IP interface brief before we make a new interface. And then we're going to be capturing that data and doing a post-output and building a table from that later on. So once I execute that command, the little star there is saying that code is executing. So we've done our pre-change output. Then we've parsed it using the useTextFSM true flag, which will then take our show IP interface brief output, parse it into a JSON format that makes it easier for us to reference programmatically. And then we apply the configuration. So we're saying send config set with those config commands. So we are creating a new loopback interface called loopback1337. And then after we make that change, we are then going to send commands to have some post output. And actually, I have some extra lines here to reset, to remove the loopback interface just for my own demo purposes, so that way it makes it easier as I go through the flow. But you wouldn't have that in your real scenario. So we have the output of sending the automated information to the device. So we create our new loopback. We verify the change, and we can see that it's now present in the output that was just rendered. So now that we have that output, we can do some data manipulation with it. So we have our list of output. So we can say for interface in our JSON output, we can print out the interface name, IP address, and the status, whether it's up or down. So if I render that, it'll run the code. And take the data and say, okay, for each of those interfaces, for gig 1, it's up, gig 2 is down, and we can see our new interface here, 1337, is up with our new IP address. And now we have some more markdown explaining what we're doing next, where we can actually do some basic math and count the interfaces for those particular devices. So we can do a sum, where we can say the number of interfaces before the change was 5, the number of interfaces after the change was 6. And so it's basically counting the number of interfaces. So that makes it easier for the network engineers, because sometimes it's easier for us to miss. I know, especially if you have more than 5 or 6 interfaces, you have hundreds of interfaces, it's good to say, oh, my change accidentally took something down that I wasn't expecting. And now visualizing the data. So they're actually built into libraries. You can see here we're using the IPython Python library to use their Markdown module. And within there, we can build using Markdown strings. So we have this basically will create a table for interfaces, IP address, status, and protocol. So rather than just having raw text, we can now plug in those values that we've parsed and display it in a Markdown table. And so we take the headers, we plug in the values, and then we do the same thing for both our pre-change interfaces and our post-change interfaces. And we just created this as a function plugging in the data, so that way we just have to call it twice for the pre and post changes. So now that information are now rendered in nice Markdown tables. So from our perspective, all we had to do is just parse the data, and this could easily be changed for other types of change requests too. This is not just for show IP interface brief. This could be for routing, VLANs, other types of data that you're working with. The key thing here is just the conceptual flow of I'm able to take my infrastructure, provide a narrative around it. I'm able to parse the information from the operational show commands I'm doing, and then I'm able to build visualizations that my network engineering team is able to quickly understand what happens to that stuff within your personal workflow. And so we have our pre-change interfaces, our post-change interfaces, and then we can actually also export the data. So now I'm using a Python library called CSV, where since we have the data in the structured data format of a JSON, we can then create a CSV file and plug in each of those values. So we're actually creating 2 different CSV files. We call one called pre-show IP interface brief and post with a timestamp. So we use the heavy lifting of Python to create a timestamp of when that data is going to be run. And so if I run this code, it will then create 2 files for us. So we have our file for today, 210. This is using American format for our date. So it's create our pre-output change and our post-output change going back. And if I go back to my home screen, I can see that those, if I refresh the page, are now should be here 20 seconds ago, showed up these two here. And so if I click into those, we can see we now have a CSV file with that same data. So we had it both in Markdown and CSV. And so that way, the Markdown says more for your team's own edification than CSVs you can easily attach and send to other teams for their own usage. So that gives you high-level flow of exactly a use case and using Jupyter Notebooks to both annotate a change and then provide verification for all of your folks. I'll go back to a few closing slides, and let's get this. Cool. So a few practical applications of Jupyter Notebooks we discussed already, but I think using them in method and procedure documents where you're helping new engineers get up and running, being able to document the flow, and then automatically have the right commands be sent. Because I know, at least when I was on the team, people would pass around, oh, here's our list of show commands, here's what we should be doing. But they weren't always the same. And so that helps you, forces you to standardize it by having it written down somewhere. And not only that, but also creates a self-documenting feature where it sends the commands for you, and then you can just review the outputs yourself. And I'd say also just for learning and coding, for people who are getting started in their coding journey, having something like a Jupyter Notebook that you're able to spin up locally is a little less daunting than using something like VS Code or some of the other coding environments out there, because it has a lot more of that interactive play and feel. So what's next? What are some other things that you could use with Jupyter Notebooks? You could automate across multiple devices. What we just showed here is just one device, but you could also scale this across dozens, hundreds of devices. It would take longer to connect to each device. But you probably want to use something like Nornir. Nornir is basically another Python framework that's similar to Netmiko, but uses multi-threading and some other bells and whistles to be able to scale out faster for bigger groups of devices. Instead of just talking to devices on the CLI, you could also be doing it with API using RESTconf, NetConf, capturing all that data without having to even parse it. And then also integrating with automation platforms, whether you're talking to DNA Center, Cisco NSO, ACI, other sources of truth, Netbox, Nautobot, different areas where you're able to then pull in the information and have it all in one place within your documented workflow. I tried to keep the examples simple here because if you don't have a background in coding, this is a great way for you to figure out what's going on. If you try to add too much initially, sometimes I find it confuses people. So you can also run Ansible playbooks on there as well, because it's just Python. So finally, you yourself can try this out. I have a screenshot here from our Cisco U tutorial. So I have a tutorial walking through this example. So if you go to u.cisco.com/tutorials, we have over 150 tutorials covering topics from security to automation, cloud, AI, all kinds of different areas where you can get hands-on experience and being able to figure out these new technologies anywhere from 15 minutes to an hour. They're very easily accessible, step-by-step instructions. So I have one here that I highlighted in the corner for this specific one using Jupyter Notebooks for you to follow along on your own. But like I said, we have topics of all different areas, and I'd love for you to check it out and learn along with me. Thanks for your time, and I really appreciate everyone showing up here. This has been great for me. Thank you.
Hello, hello, hello. Hello, hello, hello. Good morning, everyone. Thanks a lot for coming. We are starting in 3 minutes, but I just thought that this is kind of the most boring part of the presentation where you're just waiting for it to start. So I thought about not telling you a little bit of why we are here, but also because a lot of you that I have been talking to in these last minutes, it's the first time that you're here. So may I see hands for who's the first time that is at Cisco Live? Oh, yeah, I see. Ooh, there's a lot of people. That is amazing. The guy in the back said that he wanted to rest his back against, the wall. If by 11 you are already there, you have a very interesting week ahead. It's going to be amazing. It's always amazing. Every year is kind of overwhelming in terms of the amount of information that is coming to you. So it's a privilege to be on Monday. We didn't even get into the keynote. We are just getting started. You are all fresh. So it's a privilege to be able to deliver a session for you guys today on Monday. And I wanted to talk about what you're going to see during the week. It might be life-changing. We are going to be seeing so much amazing stuff. And one of the key things that I would advise you, newcomers, for Cisco Live, is to be able to bring back home as much as you can. Things that you can use. Because if you attend a session and you don't bring anything back home, then it's useless. Because you have listened to someone doing something, but if you are not bringing it back home and being able to action on that, what's the point, right? So what I'm going to show you today is something that you can bring back home and that you're going to be able to leverage. So I'm going to tell you all about that in a few minutes. Just want to be conscious of time. We got 1 more minute. When I get the heads up from our guys, I'll get started. Who's coming from more than 6 hours flight? 5 hours? That guy. Where are you coming from? I cannot hear you. From India. 6 hours? More than 8 hours. Wow. I hope this is worth it. And you? Iraq, which is 5 hours. Okay. We get another Iraqi there, 5 hours as well? That's good. Okay. Are we good to get started? Yeah? Great. So, thanks a lot for being here. I would like to give you something that you can bring back home that is really useful for you. I would like to describe something that is life-changing, but honestly, we're going to talk about a service mesh. So maybe not, up to that, but it's going to be very, very interesting. The main thing about the session today in these 30 minutes, we are going to see just practical use cases, which is something much more interesting than just a theory. So if you're already familiar with the service mesh, we are going to just spend a couple of minutes in that. My name is Julio Gomez. I'm an engineer working on programmability and AI, but today I'm going to talk about one of my passions, which is cloud native. As I said, by the end of the session, you're going to be able to take back home something that you can use, that you can replicate, that you can demonstrate to your colleagues, if you're a partner, to your customers. You can brag about it, about what you're going to be able to experience today. So the agenda is very, very short. Why? Because we just have 30 minutes. So we are going to talk about what is a service mesh. If you are not familiar with it, we are going to just have a 2 minutes quick intro into what a service mesh is. And also the use cases, which is kind of the body of work that we are going to do today. So what is a service mesh? Again, hands up. How many people here know already what is a service mesh? 1? Okay, nobody else. That's fantastic. I'm going to do a quick intro, 2 minutes, for people that have never heard about this. This is a challenge. Okay, so a service mesh is, this sentence describes it very well. It's first an open platform. It's something that can be used in your code for any microservice that wants to use it. It's about service interactions. When you have small pieces of code called microservices and they want to interact among them, you can join. They are interacting among them. You can see that they have common needs. They have needs for communication in terms of authentication in between microservices. You have needs in terms of security, of policy, of observability, and all of that can be abstracted. So that's what it's doing. It's helping the service interactions. And they do that in a consistent and secure way. Why? Because otherwise microservices would have to implement their own way of doing it. If I have to implement authorization and authentication against another microservice, I have to do it manually as a developer. Why not putting that in an abstraction layer separated from everything? That's the service mesh. That's the power of the service mesh. So the idea in terms of implementation is to do that with a small piece of code, which is another container that sits next to your container and does everything for you, all the communication-related needs. So deploy lightweight sidecar proxies. Those are the small containers that you put next to you, and they handle all the ingress and egress traffic. They do everything for you. And that's fantastic because I don't have to implement it. As a developer, I don't have to care about that. They attach transparently, meaning that you, as a developer, do not have to do anything special. Any packet that goes out of your microservice or goes into your microservice is handled by that sidecar proxy, by that envoy, by that small microservice from the service mesh. It mediates all the inbound and outbound traffic for all the services, and it provides a number of features. And that's amazing because you can even grow it as you need. You can create observability features. You can create policy features. You can create security features. And all of that is done transparently. That's beautiful, right? And it enables observability, security, and control features. For me, when they explained this to me in this 2-minute thing, it sounded like a unicorn. Man, that is great. As a developer, I love that idea. Tell me more about that. Well, today, as long as we only have 30 minutes, we are going to talk about this, the control part. We are not going to talk about security or observability. We are just going to talk about how we can find use cases that control the traffic and does something with it that it's really useful. So service meshes are provided by many different companies doing different approaches. Today, we are going to talk about something that has been the de facto standard called Istio. And Istio is coming from the implementation that Google and IBM did of this specific need of a service mesh, taking the work that was done by Lyft, the car company, you know Lyft? So they did an envoy approach, which is the sidecar proxy, and they leverage it. So the structure is very simple. You have a central component called Istio daemon, and it does the centralized features that you need. It's kind of the brain of the solution, of the service mesh. And this brain provides you with service discovery. It discovers when there is a new microservice here or there, and where it needs to deploy a new microservice next to it, the sidecar proxy. It also provides those in mesh topologies, and it provides the certificates. When you have to do mutual authentication or authorization, you need certificates. Well, this is the guy that provides the certificates to all the different proxies so that they can communicate in a secure way. That's the role of this central Istio. And then you have the proxies, the small containers that sit next to your microservices. And those guys are the ones that are attached to every microservice, and it's the connection point. Every packet that goes out or into my microservice goes there. That is my 5-minute introduction into a service mesh. Is this more or less clear? Yeah? Okay, because now I'm going to jump into what is more interesting, which is the use cases. Even though I'm a thin guy, I have fat fingers. I am not good at speaking and writing at the same time. So what I'm going to show you is something that's pre-recorded, but it's real, and you're going to see how it works. So in order to do demonstrations, I need to bring you a real application that is based on microservices. So the application that I have for that has been created by one of our colleagues that must be around here. His name is Hank Presson. He has developed one application that is very, very useful. You can use it to determine who is the best superhero. So it gives you a front end, and you click, and you find who is the best superhero. It's called My Hero. So this microservices-based application has 3 microservices, and we are going to use it for our demonstration purposes and the use cases today. So it has the front end, My Hero UI, which is an Nginx microservice. It's a front end for HTTP. Then you have a middleware that is done on Python, and then you have a very fancy database in the backend, which is a text file. So yeah, you see, it's for demonstration, so it's more or less working. So this is what we are going to use, and there's an interaction in between all of them. So what we are going to do is we're going to deploy a service mesh here in this, so that you can have small microservices attached to each one of these microservices. Now, let's start. We are going to cover 5 use cases, okay? So let's start with the first one. The first one needs to have a little bit of a setup. I need to set it up before I start developing the use cases. So the first one is about the base situation. And the base situation is that for the front end, what I'm going to see in my browser when I go voting for my best superhero, I'm going to get 3 different front ends. Why is this important? Because when a developer creates something, it has a life cycle. And that microservice is going to evolve a long time. But when you have a new version and you have made changes in your code, you don't want that new software to show up immediately for all the traffic. No. What you want to do is you want to have different versions running in parallel and then selecting the one that you want to use for a certain specific piece of traffic. So I have 3 versions, version 1, version 2, and version 3. And each one of them has the same code running, the same base code, but it has small modifications for version 1, version 2, and version 3. So the way that I configure this, it's with a manifest. A manifest is a YAML file. A YAML file is a text file that has a certain structure, like the one that you are seeing here. I cannot go into the details about what are the specific fields, but it's a standard YAML, the one that you see for many other applications. But what I want you to see here is that basically what we say is, when you go here, when you go to the My Hero UI, the user interface, that front end, you have 3 different subsets, and each one of them has a label. Label version 1, label version 2, and label version 3. That's it. That's what I want you to understand. We have 3 different ones, and they all interact with the middleware and with the database. That's it. OK. So let's go with this setup. What I can do is I can first take a look with Kubernetes. Obviously, this is in a Kubernetes cluster. It's a Kubernetes deployment. We have here a number of pods that are running, and I'm going to show you the labels that they have. The labels for my Hero UI, you see version 1, version 2, and version 3. That means that there are 3 microservices, each one of them running the code for version 1, version 2, and version 3. Still with me? Yeah? OK. This is the way that the application looks. It's a front end with the photos of all the superheroes. You just click, and it stores the votes in the database, in a text file. OK? So the way that you are going to be able to differentiate if we are using version 1, version 2, or version 3 is the title that you see that says make one voice heard. That's version 1. If I click on reload, you see it says make 2 voices heard. That's version 2 of the software. That's the microservice in version 2. And if I click reload again, it says make 3 voices heard. That means that it's version 3. That way, when you reload, you are going to one microservice, the next one, or the next one. The 3 of them are load balanced, and traffic is distributed evenly among them, among all the different microservices. So that's the initial setup. Now, with this, we go into the first use case. As a developer, I have published new code, a new version for that front end. That's version 2. It's more advanced than version 1. So I want to make sure that I can route some of the traffic to that specific version. So what I can do is I can create something called a virtual service with a text file in a manifest. With this virtual service that says, when you go to userinterface.com, whatever domain you are in, when you go there, I want you to route it to the destination with the label V1. Remember, all the traffic I want it to go to V1. Even though I have 3 versions running in parallel, I can policy it. I can say traffic goes just here. So if I apply that, all the traffic will go to version 1. So you see, Kubernetes kubectl is a kubectl is the command that we use. Apply the file all to V1, all the traffic to version 1. And that's a YAML file. It's a manifest. If I apply that, you see that when I click on reload in my browser, what will happen? All the traffic will go to version 1, exactly. So version 1, click, make one voice heard. When I reload again, it goes to version 1. There you go, version 1. It's always going to version 1. If I click again on reload, version 1. It always goes to 1, never to 2 or 3, because I have defined a policy, a destination rule that says everything goes to version 1. So think about it. As a developer, I can have code running in production, in a production environment, and do not redirect traffic to it. It's just going to a specific subset, a version 1. Great, so that's use case number 1. Now, moving forward, what is the next step for a developer? Number 2, I want to try and inject delay in the communication in between the microservices, from the user interface to the middleware. I want to include artificially a delay. Why? Because I want to see how my application reacts. If there is a problem in the network in between two microservices, there might be that my code needs to handle that delay. So I can artificially inject it to see how my code reacts. So again, with a virtual service, the only thing that I have to do is define a fault that says, for 100% of the traffic, insert a fixed delay of 5 seconds. It means that when user interface needs to communicate with the next middleware microservice, I'm going to inject a delay. And that way, I'm going to see how my code reacts. So that's the only thing that I have to define. That way, when there is communication between the browser and the My Hero UI version 1, you will see that there is a 5 seconds delay. How do we see this? I apply it with kubectl again. I apply the YAML file, and you are going to get this YAML file. You are going to get everything, as I said. You are going to get everything so that you can bring it back home. When you apply that, you will see that going to the browser and clicking on reload again, it's going to show you the delay. But how do we see the delay? How do we see that it's really happening? Well, I can go into troubleshooting or debug mode in my browser, in Firefox in this case, but you can do it in whatever browser. And you can go to network, the network section. You go there, and then you click on reload, just to see how it's going. Click on reload, and then you will see here all the steps about the request. So you will see that there is an additional delay. These long bars that you will see here is the delay that you have when you're asking for requesting new resources. So you see 5 seconds, 5,000 milliseconds. When you request the specific JavaScript, when you request the JavaScript for main and for the application, all of that has 5, 5, 5. You see the same? And then, as I do additional requests, it's on top of that. On top of those 5, then you have another 5. That's why we get to 10 seconds. So you see in real life how your application behaves, how it's impacted by the delay that you might have in the network. The customer, the style sheets, you know, an additional 5 seconds, 5 seconds. You know, for every additional request, you're going to get additional 5 seconds. So it's going to slow down your application, but it seems like it's still working. It's slow, but it's working. Some other applications might not work if there is a delay. So you see, I just wanted to demonstrate 5.5, 5.5 for additional requests, for the images, the JPEGs. So all of that is included here. OK. So I'm going to reset it and go everything back to V1 without the delays, you know, so that I can go into my next use case. Use case number 3. Use case number 3 is about simulating another fault, not a delay, but rather an HTTP error 500. When your backend is not working, when the microservice is not working. If this thing stopped working, what happens with these guys? How are they going to be impacted? I can simulate it. I can simulate an HTTP abort. That's the message. So I can define another virtual service, and the fault, instead of delay, is an abort, an HTTP 500. And I can just define even the error code that I want to return for 100% of the traffic. Let's see what happens when I apply this. Apply the manifest, HTTP abort, a standard YAML file with the code, the text that you have seen. And then I go back to my browser. Again, I'm going to do the same. I'm going to reload and see what happens. Oh, suddenly I don't get the photos. I don't get the pictures. Why? Because the backend is not working. So there is an abort error, and that's why the HTTP 500 is simulating that the backend is not working. So I can see how my application reacts to one microservice not working. That's the power of the service mesh. It's inserting faults artificially. So nothing, no images. Great. Going back to the initial status, again resetting, so that I can go into my next use case. My next use case is use case number 4. This is a gradual migration. Why is this important? As a developer, I have new software coming all the time. But again, I don't want to automatically put all my traffic from all my customers into that new service. Why? Because I'm just testing it, but I want to test it in production. I want to test it with real traffic. So how do I do that? Well, the service mesh provides that functionality, provides you with the ability to say, OK, you have for this destination, you can have a subset v1, version 1, the one that says make one voice heard, for example, and then version 3, the one that says make 3 voices heard. Those are examples of different software versions. And I can say 50% of the traffic goes to one of them, to version 1, and 50% to the other one. And that way I can test with just half of my traffic. I don't have to do it with everything. Again, the developer does not have to do anything. It's just a service mesh via the Envoy sidecar proxy container that it has next to it that handles everything for you. So this standard YAML is the one that I will use to implement this. From my browser, traffic will go 50% to version 1, and 50% will go to version 3. That's the idea, right? So how do we do that? We apply the manifest in exactly the same way that we have done with the others. You go here and you say kubectl apply file -f, and then say file number 4 is 50% to v3 and the other 50% to v1. You apply that manifest, and let's see what is the effect. When I go here and I click on reload, what are the options that I can see in terms of versions? Version 1 and version 3, the ones that I have load balance, right? No version 2. So I can only see make 1 and make 3, the 2 versions. Let's see if that is the true. It's true. Make 3, I click on reload, make 1, you see, it's only balancing in between 1 and 3. It's not sending anything to 2. 1 and 3, 1 and 3. I have done that, and the developer does not have to be even aware of what we are doing. The SRE, the owner of the cluster, can do that for you. So balancing in between 1 and 3. Great. Now, once that I have done that, if version 3, which is more advanced, it's good, then I'm going to move 100% of my traffic into version 3, right? Because it's working. So why should I stay with version 1? I'm going to move everything to version 3. So in order to do that, I apply this manifest. This manifest says, wait 100. 100% of my traffic is going to be sent to version 3 because it's more advanced. So everything goes to subset labeled with version 3. As you can see, the manifests are quite readable. You know, it's very intuitive. So with this one, I apply it. And I apply it exactly in the same way that I have been doing until now. kubectl, apply, file, 5 UI, all traffic going to v3. These YAML files are what I'm showing in my previous slide, okay? It's nothing else. It's just a destination rule. With that, when I go into my browser and I click again on reload, what am I going to see? What version am I going to see? Version 3, no version 2, no version 1. If I reload, it always will say make 3, make 3, make 3. It's the only version. Imagine, as a developer, you have new software that you have in production. You have tested it with a subset of the traffic, and now you are going to be able to move all your traffic gradually, the percentages that you want until you go into 100% traffic into this new version. Still with me? Yeah? There you go. Let's go now with last use case. Well, this is make 3. It's going to be 3 all the time. Reset everything to version 1 so that I go back to the initial configuration. And here, I'm going to go and take a look at the logs. Because for my last use case, it's a little bit more complex, so I want to show you exactly what we are doing. For each one of my version 1, version 2, and version 3, I can show you the logs. What is happening? What is happening? It's an Nginx, so I can see the logs that are happening. So this is when you only see the 200s, the 200 codes, HTTP 200, it means that the application is quiet. This microservice is not receiving traffic yet. No one is voting for superheroes. So this is version 1. So in version 1, it's very quiet right now. If I go into version 2, which is another tab in my terminal, I go into version 2, and I take a look at the logs, and again, quiet, 200s. Everything is quiet, nobody's voting yet. This is the initial version. Now, with this, when I click on reload, what I'm going to see is that it's going to load balance, and it's going to go to 1. If I reload, I will see that the logs for version 1, things are happening. It's not 200s anymore. Now there are superhero peaks, and I'm seeing You know, the JPEGs are being served. You know, things are happening. The logs for someone voting. But it's going to version 1. It's going to version 1. When I go into version 2, to the tab for version 2, it's only 200. Traffic is only going to version 1. That's what we are seeing here. Traffic is only going to the tab where we see version 1, nothing to version 2. Yeah? This is the initial setup. You need this for the use case. The last use case that I'm going to showcase is traffic mirroring. Traffic mirroring. Traffic mirroring means that all the traffic that goes into one microservice, like here, all the traffic from my browser that goes to one microservice, I'm going to create a copy, and I'm going to send it to version 2. Why is this useful? As a developer, this is amazing. Why? Because I developed version 2. And I'm not very sure about, you know, how good is it going to be, the quality of my software. It's like, oh, I'm going to test it. But I don't want to mess my customers' traffic. So how do I test it in production? Well, very easily. I make a copy of the traffic that goes into version 1 that is being served correctly by the old version, make a copy and send it to version 2, and see how version 2 behaves. The end user is not impacted, but I'm receiving a copy of real traffic. Really cool, right? The service mesh does that for you. How does it work? Here you have the manifest. The manifest says, when you are going here, I want the version 1 and version 2, destination version 1 is going to be mirrored into version 2. That's these arrows. I can even do the fancy thing, right? Oh, yeah, there you go. This arrow is the traffic goes here, and this is the mirror statement from V1 to V2. That is really, really useful to test in production, to test with real traffic in production. So applying this manifest is exactly the same as we have done until now. Apply the manifest, kubectl apply -f that file, and once that it's applied, we will see the following. Version 1, it's quiet for now. I have not voted yet. Version 2 is quiet as well. But when I go and click on reload, remember, something is going to happen. When I click on reload, it's going to serve version 1. I go to the logs for version 1, and things are happening here. But now take a look at this. When I go into the version 2 logs, the logs in the second tab, you see that things are also happening here. This version 2 is not serving real customers. It's just receiving a copy of real traffic to see how it behaves. For a developer, this is the best thing since sliced bread. Because now suddenly they can test with real production traffic, with a copy of that. And they have had to do nothing. It's done by the service mesh. Istio has done that with a few lines. Very, very powerful. So you get the copy here. So these are the 5 use cases that I wanted to show you today. Now, what do you do with this? It's like, yeah, I mean, the demo is great, I hope. The demo is great, but so what? I mean, that's a classical question, right? So what? Well, so what? This is what I'm doing here. I'm 50 right now, and I see myself going down, down, down. My memory is very, very bad. So the way that I handle that is by writing love letters. But the love letters that I write are to myself, to my future self, because I know that I will not remember anything. So I write love letters to the future Julio, where I say, hey, old guy, you know, you're not going to remember this, but I'm going to write it for you. And I document everything. And the way that I document everything is on something called hands-on with DevOps. Why? Because all of us here in this room, well, not room, in this area, we all love things that are hands-on, right? I mean, it's great to hear someone doing a session, but it's much better to be able to replicate it ourselves. So that's what I'm documenting here, a hands-on document for everything DevOps, with an extra emphasis on hands-on, right? Because I don't know if you guys have been to a lot of DevOps sessions, but they start talking about the 2-pizza team, and they start talking about the organizational changes that you need to do in the company. It's like, yeah, but what are the tools? What are the things that I can do with this? This is what you can do. And I make it publicly available. This URL, cs.co/JulioDevOps, has everything that I have shown you today so that you can replicate it back home absolutely for free. and much more. You have everything to get started from scratch on Kubernetes, Docker, Istio, Helm, CI/CD pipelines, serverless, Octeto, all the different tools that we have that are relevant to developers and SREs in the DevOps world. So if you want to take a photo of something, this is it. This URL, please remember it. It's a GitHub repo where you will gain access to everything. And when I say everything, you probably have seen a lot of sessions that say from zero to hero. No. If you follow this document, I guarantee you go. You are going to be a real hero on the topic of DevOps and the tooling associated with it. Yep. So go for it and reach out to me. It's a public GitHub repo, so you will be able to reach out to me very, very easily. Also, we have the Webex application where we have a room with all of you guys that decided to join, and myself. If you want to reach out to me, questions, whatever, if you cannot access the document, you have doubts or whatever, I'm going to be available here for any questions. Important, please fill in your surveys. We are evaluated as speakers on the surveys. My boss is going to evaluate me on the session, on the results that we got there. So please complete your sessions, complete your surveys as soon as possible. Continue your education. Cisco Life is great. Cisco U also has a plethora of content if you want to follow up. And with that, thank you very much. Thank you.
Do we have audio? Can you hear me? Oh, perfect. Hello, everybody. Welcome to the Cisco U Theater. So just to make sure that you are at the right place, you are here for stay connected, stay informed, Splunk meets Webex for observability session. Before we get started, a bit of housekeeping. You can ask me any questions you want after the session through the Webex app. Make sure you have the Cisco event mobile app installed. Go to the session, join the discussion. I will be monitoring that space until the 28th of Feb. So a little bit about me. My name is Osama Hantool. I'm from Saudi Arabia. I joined Cisco back in 2017. I started as a collaboration technical solution expert for the collaboration, and then I joined the field in Saudi Arabia as a solutions engineer focused in the public sector. I'm a DevNet and programmability enthusiast. I've participated in few DevNet Express sessions as a speaker and a proctor, usually for the internal ZAN partners. As you can see here from this picture, I love skiing. This picture is not in Saudi Arabia, although we do have a bit of snow in the north, but maybe when we host the Winter Olympic. So what do we have today? So we will start exploring the role of sensors and analytics within the video devices and how can the facilities teams get advantage of them. And then we'll discuss the benefits of integrating Webex with Splunk and how it would create a world of possibilities and use cases to many teams within the organization. Today, we'll take the facilities as kind of a proof of concept or a proof of value for this integration. And then we will follow that with a live demo, bringing everything we discussed into live. Through a step-by-step guide, we will demonstrate how easy it is to configure this integration, bringing the Webex data to the Splunk environment. So let's get started. By show of hands, who uses Webex in their organization? OK, great. Who uses Webex devices in their organization? Less hands, but great. Who has interacted with the built-in sensors of those Webex devices, or at least has seen them in action? OK, less hands. So you may already know that Webex devices provide great collaboration experience for people working from their offices or from home. They are equipped with powerful sensors out of the box. Those sensors aren't just for data enthusiasts or people responsible for the workplace optimization and safety. They can provide critical and timely information to employees, which can drive behavior, build trust, and at the end of the day, provide great workplace experience. Have you been in a meeting room that felt crowded and stuffy, and you just needed a few minutes to break away from that meeting room? I know that I have. Sensors, analytics, and automation solve this issue by providing the information that people need to make informed decisions about where and how they would like to work. A common argument against those sensors is that they are expensive, difficult to install, and require a dedicated team to manage, track, and optimize spaces. That may be true for ad hoc devices or sensors, but Webex devices come equipped with powerful sensors out of the box. So no further installation. It's all within the video device. You can get insights to optimize every workspace at your organization. So if you work in the human resources or you work for the facilities department, sensors and analytics gives you enablement or to know where your employees are spending their time and whether they are staying within healthy environment and the criteria for safety, comfort, and energy saving are met. The historical reporting and analytics are reported directly to the control hub, more specifically under the workspace tab. So you can know how your environmental metrics are trending within your organization. Those telemetry include temperature, relative humidity, presence, people count, acoustic, and noise. So facilities, they have their own tools and more familiar workflows. So having such valuable information reported directly into the control hub, which by itself contains information more focused on calling, meeting, and a contact center, which are not the core or part of their workflows that they are using daily, might be challenging to them. So what if there was a tool more tailored to them that will help them with powerful search and being able to correlate different data points? An example would be correlating the Webex telemetry with the current building management system that they're using, and built-in machine learning to help them detect anomalies, predict trends, and helping them with repetitive tasks. Longer data retention compared to the default 3 months that the Webex Control Hub provide. Proactive monitoring to help them detecting issues before they escalate using modern and nice-looking dashboards. And last but not least, automated alerts based on specific conditions that they could set. That platform would be Splunk. But before we dive in, let's discuss the different Splunk platforms out there, starting by the Splunk Enterprise, which is the core product for searching, indexing, and analyzing machine data from virtually any source. You may already know the Splunk Enterprise because it's used in IT operations, security, and analyzing machine or business data. Then you have the Splunk Cloud Platform, which is a cloud version for the Splunk Enterprise. And last but not least, the Splunk Observability Cloud, which is a suite of tools for modern and native cloud environments. Those tools include Splunk Infrastructure Monitoring for real-time monitoring of infrastructure, the Splunk Application Performance for tracking the application performance, the Splunk Log Observer, which is a log analysis tool basically for DevOps and developers. Last but not least, the Splunk Synthetic Monitoring for testing application and service availability. So today, we will demonstrate and learn together how to do this integration between the Webex Control Hub using its numerous APIs that are available in the platform with Splunk Enterprise or Splunk Cloud Platform. They are technically the same steps. So from the Webex side, we will learn how to create an app integration. So basically, it allows you to authenticate and to invoke those APIs on behalf of another user. The APIs support OAuth 2 standard, which allows the third-party integration to have an access token, basically, so they can invoke those APIs without the need to ask a user to put their username and password. We will also learn where we can find the Webex APIs and how we can use them. From the Splunk side, we're going to learn about the HTTP Event Collector, or HEC, which enables you to send data and application telemetry or logs to the Splunk environment over HTTP or HTTPS protocols. So when you configure the token, you're going to configure also a logging library or HTTP client to send the data to the Splunk deployments in a specific format. We'll learn more about it in a bit. So in today's session, it's kind of a showcase that with few steps and a low-code integration, you can come up with interesting use cases that are more tailored to your organization needs. So how can we do this? So basically, just 5 easy steps. First step is going to be on Webex. We're going to create an app integration. Second step is going to be on the Splunk side. We're going to learn how to configure the HEC, or HTTP Event Collector. And then we're going to also learn where we can find those APIs, as we mentioned, on the Webex side, and how we can use them. And then we will use all those parameters in our middleware application to start sending those events. Eventually, we're going to come up with a dashboard. And that dashboard is going to be more for the facilities. They can correlate data, as we mentioned, and they can spend their daily tasks on there. So first step, creating the Webex integration using my Webex APIs or Webex apps. So how to do this? We need to go to the developer platform, so developer.webex.com. If you click on this, so at the top side, you can see your profile picture. Click on that. Go to my Webex apps, create a new app, and create an integration. You need to give it a name. Let's call it Cisco Live Webex and Splunk integration. Give it an icon. Give it a small description as well. I'm going to use the same as the name. And then you're going to configure the redirect URL. So basically, after the authentication is done, the integration will send you to that specific URL. My code is going to be on my local machine. So I'm having my local machine listening on a specific port. Let me configure that. And then you need to set the scope for that. So you can be granular on what the integration has an access to. For the sake of today's demo, we're going to go for Spark All, which is basically giving you access to everything. So if we scroll down a bit, so it will give you a full access to your Webex account. Add this integration. So congratulations, you have the parameters here. We're going to use the client ID, the secret, the client secret as well, and the OAuth authorization to basically allow you to authenticate for the first time. So initially, you need to use this URL to grant it access to your organization. So let's copy paste it here. Give it an admin account. So an admin account has an access to the control hub. Put the username and the password. And then grant that access. It will try to redirect you to the URL that you specified. The application is not running, so there is nothing here to show. So this is step number 1. Step number 2 is going to be on the Splunk side. We're going to learn how to create the HEC. So I have my Splunk Enterprise installed on my local machine. So this is my Splunk. I need to log in with my credentials. You need to go to the settings here, data inputs. And here you can see the different ways that Splunk can get information. You can configure a specific port on TCP or UDP, typically used for syslog purposes. You can also configure a directory in your machine that Splunk monitors. In today's session, we will learn about the HTTP Event Collector, and that's what we need for this type of integration. So you need to create a new token. Give it a name here. Let's call it Cisco Live HEC. Click on Next. You need to specify the source type. So we're expecting to receive data through JSON. So we need to select on Select and go to Structured. Click on JSON. And also, you need to create an index or choose an index. So an index is a repository of a data. So basically, where you're going to have the logging library. So let's go to create a new index. Give it a name. Let's call it Cisco Live _ index. Save that index. Make sure it is selected. Review, submit. And here you're going to get the token value, which you need to use in your application. So this is step number 2. So step number 3, the APIs themselves. So where we can find the APIs is going to be on the same developer.webex.com, but in this case, it's going to be under the documentation tab. So if you click on this link, you can see on the left side, if you scroll a bit down, the API section. Scroll a bit down to the full API references. Go to the workspace metrics here. Click on the Webex metrics. It gives you introduction about this APIs, what type of parameters I'm expecting, etc. So I can see here I need to specify the workspace ID, and I need to specify the metric name. So the workspace in Webex means typically a place where people work. That can be a conference room. It can be your office or your home. So every workspace within your organization has a video device. And every device you have has to be assigned to a unique workspace. So I know my workspaces. I don't know the IDs of them. Fortunately, there is another API that can list all the workspaces, and you can use the IDs from there. So I have it here. And I need to specify the metric name. So if I scroll down, I can see the metrics that this API accepts, which are the sound level, ambient noise, temperature, humidity, TVOC, and people count. Does anybody know what TVOC is? So TVOC is the air quality. So we need to get the temperature, so I'm going to use the temperature parameter here. So if I run this API, I'm expecting to see the temperature reading of this particular workspace. So if I scroll down, I can see that the temperature here is in Celsius. I can change it to Fahrenheit if I want. They are sorted by newest first. So I see here from 10 to 11, the temperature has a maximum of 23.3 and a minimum of 23. So this is the API that I need to use in my application. So this is step number 3. So step number 4, we need to build our middleware application. So I already created a project. I uploaded it to GitHub. So basically, if you go to that project, you will see all the parameters and functions there. Everything is documented, so you can basically reverse engineer it to whatever use case that you're trying to do in your organization. So if I go to my code, I gave it a bit of introduction. So it sends environmental reading to the workspace, to a Splunk deployment using HEC. You need to have Python installed. Those are the steps we discussed. So first step, we created the integration on the Webex. And then I'm going to use those parameters, which were the client ID, the secret ID, in the code itself. I need to replace the URL by the authorization URL we got in the index.html. And then you need to fill in your workspace IDs, which we showed you earlier. And this is a bit of, if you forgot, you can go to this URL. It gives you all the data you need. Also, you need to replace the HEC token and the Splunk URL. So as I said, my Splunk is installed on my machine. So if I run this code, I expect first to get an initial authentication from the admin. So basically, you authenticate against the Webex server. You get the access token. And then the application itself is going to refresh that token with time. So let's go to the code. So you see here, I have the client ID and the secret ID from the initial step. This is my redirect URL. These are the HEC or the Splunk details. This is the HEC token and the Splunk URL itself. These are the workspace IDs. I have 3 workspaces, one in Riyadh, one in Dubai, and the other in Doha. And if you scroll down, these are the functions for handling the OAuth integration. If you scroll a bit down, so after the authentication is done, the Webex Splunk function, which is this one, is going to be invoked, which by itself will schedule calling those APIs and sending them to Splunk every single hour. So you can configure this to be more frequent or less frequent as much as you need. Just a bit of rundown on the function. So it calls the temperature function. It loads the workspace IDs. And then they're going to call the APIs that we experimented with. So let's run this code and see how things are. So if I go to my terminal, let me have it next to the browser. So let me run the code here. So I can see I'm listening on the port 10,060. So it says grant integration access. Click on grant. Give it the username and password for the admin. And I can see here the authentication is being exchanged. You can start sending events. And it says here, please put the highest rating for this session. This is a bug. Don't worry about it. So I can see here the JSON files are being sent from the code to the Splunk environment. So let's go to the Splunk and see how the data are being shown. So if I go to my Splunk, go to search. So I created the Cisco Live index, but actually this code is sending to another index called main. So let's search. So you can see here the data is being received on Splunk. Let me enlarge this so you can see a bit better. This is the temperature reading of Doha, temperature reading of Dubai, and temperature reading in Riyadh. The power of Splunk, it gives you kind of analysis on all the data being received. So if I click on the temperature, I can see the top 10 values that I'm receiving, the counts of them, how frequent they are. And I can see an average over time, maximum over time, and minimum over time. Also, I can visualize this data. So if you go to visualization, click pivot, OK. Here, it asks you what type of values you're trying to show. I mean, typically, in Splunk, you're getting a large JSON files. It has a lot of values and a lot of metrics. So what I want to show is the temperature. So I need to put this here. And you can choose some of the values, average, maximum, or minimum. I'm going to go with average, add to table. On the left side, I can choose how I'm going to visualize that data. It can be a line chart, a pie chart, an area, etc. So let's go to line chart. So I can see that these are the values of the temperature. If you scroll a bit down, you can connect that to have a kind of a nice graph. And if you saw earlier, we created 3 workspaces, or I'm receiving data from 3 workspaces. But this is only one line chart, because it takes an average of all of them. I can show them individually. If you click on the color here, specify the workspaces. So I'm having 3 kind of lines for every single workspace. So this is for Dubai, this is for Riyadh, and this is for Doha. I can also save this to a dashboard. So if you go to Save As, Dashboard Panel, you need to give it a name. So let's call it Cisco Live Dashboard. You need to also fill the model title and the model ID. Click on Save, View Dashboard. So this is my line chart. Typically, you're correlating this data to other data that they are using. For example, we mentioned the building management system that they're currently using. Also, you can put nicer graphs to, for example, show the current temperature in one of the workspaces. So go to Edit, click on Add Panel, New. Let's go for a marker gauge. You need to give it a string. So what's a string? A string is basically an SPL query to extract that data I'm trying to visualize. In this use case, I'm showing the temperature for a single workspace currently. So if I go here, I need to specify the index first. So specify the index. Let's call it, let's use main. I'm searching for a workspace. I'll choose Riyadh here. And then fields, temperature. So you can also specify here for the last 60 minutes or 15 minutes. Let's go for 60 minutes. I need to add it to the dashboard. So this is the gauge. So it shows that the temperature roughly is about 20 degrees. And I created the dashboard beforehand, kind of illustrating everything we are discussing here. So let me show you that dashboard. So if you can see here in this dashboard, this is the line chart I created beforehand. And these are the current temperature in Riyadh, Dubai, and Doha. I have an interactive map. If you kind of hover on a country, it tells you where that workspace at and what the current temperature is. So this kind of brings me to the end of my demo. Basically, the last step was to create the dashboard. So what did we learn today? So by integrating Webex Control Hub with Splunk, it unlocks powerful insights to enhance the overall value of your Webex and Splunk. This integration enables you to improve decision-making through advanced analytics, machine learning, and basically helps you as well to simplify operation through automated alerts. It also helps you to kind of have a longer data retention and seamlessly correlating data through different platforms. So thank you very much. And a bit of teaser, you didn't hear it from me. We are building this integration natively between the platforms. It's on the roadmap. It's nothing committed yet. So look forward to that. Please fill in the surveys. You will get a unique T-shirt by the end of this event. And thank you so much. Appreciate it.
Good afternoon, and thanks for coming. I'll start with a situation. Imagine it's a Friday evening, and it's almost weekend, and then suddenly your phone rings, and you look at it, and then one of your production server is having issue. What is the first thing that comes to your mind when you look at that? Maybe you're frustrated, you are stressful because you're looking for a relaxing weekend, and then you see this, and then we are all been there, gone through this, right? So in this presentation, what I'm going to share with you, some of the things that we have encountered and what we did to come out of that, and maybe you have a better way to handle those situations, and you can share it with us. So it's going to be a collective learning session, and then we'll see how we can build a more resilient and a safe system. At the same time, you also have very stress-less Fridays, right? That's going to be the theme of this session. So you can join the Slido, you can join the Webex team. Feel free to share what some of the things that you are doing, how you handle your production incidents, and what some of the things that you are doing, and what some of the proactive steps you are doing for that. By the way, myself, Raja, and this is my colleague, Marcin. We are part of Cisco U engineering team, and we'll be sharing our practices that we do in order to take care of the security and resiliency for Cisco U. Cisco U in numbers, it's been in general availability for the last 18 months. So we have around 310K users. It has got 74 microservices, and it's on the modern cloud-native Slack. It uses 54 AWS services, and then we also use Cisco Multicloud Defense and Splunk. And more importantly, we get around 3.1 million attacks so far in the last 18 months. Are you seeing attacks on your production workloads in the last 6 months increasing? In your production workloads, are you seeing cyber attacks increasing in the last 6 months? No, it's not? Okay, but we are noticing, and that's why I want to see, are you noticing that? Okay, so we want to share our experience, how we significantly improved our security, like how we detect and prevent the cyber attacks around 3.1 million, and what we do for that, and how do we increase our reliability by reducing the SLA for the breaches. And most importantly, how do we improve our operational efficiency by increasing the debug time? Because when the issues happens, the first three questions that come to our mind is why it is happening, where it is happening, and how quickly can I fix it? And what is some of the techniques that you can do to get to that is what we will see in this session. Yesterday we did a full presentation for all the techniques that we did, but in this 30 minutes, I'll just talk about the importance of doing an integrated tooling and then an observability that will help you to actually deal with how do you react to the production outages, and also how you can proactively identify where are all the bottlenecks in your system so that you can identify them and also you can remediate them. So one is the integrated tools. You might be using some cloud provider console, and then you will have a log mechanism where you have all the logs being stored. You will use any intrusion detection system that you use in your production systems, any intrusion detection systems or any scanning tools, any security scanning tools. So yeah, so you'll be using more of those tools, but then most of these tools will be fragmented. For example, if you are using a software and it is having all the third-party software components and you're doing a scan, the log will be in one system. And then your application logs will be in one system. Then if you are using an intrusion detection logs, it will be in one system. So there'll be 3 different systems at a minimum, and then it will be more also. So the problem with that approach is you will always have a fragmented view of what is going overall within your system. So it's very important for you to have an integrated tools. Even though if you have the tools, you have built it or you have got it from different customers, always try to have an integrated view of all these things that are happening. As a use case, I will tell, like how we are having a multi-cloud defense that can be integrated easily with Splunk, and that's just a use case, but you can try to look at it like any of your security tools to be integrated with Splunk as well. The next one is you embrace observability, and why observability is important. For example, if you are having your application that is running and you want to identify a problem happening, which part in your system is having a problem, to pinpoint that, you need to have traces so that you can pinpoint this is a part of the problem that is having. Otherwise, you have to look through the logs, you have to debug your system, and it's very difficult to do it in production. You will not have access to it, so it's very important to have observability. And this is what we will cover in this session. So tool integration, the top challenge is if you have multiple different tools taking care of security, you will not get a correlation between those tools. If you are doing a scanning, and then all your scan results are stored in one place, and then if you are doing network intrusion detection, that's in one place, and then you are having your software, your security testing, that's in one place, and you want to see, am I being attacked on any of the vulnerabilities? For example, if someone announces a zero-day vulnerability, and the software that you are using may be using that third-party component, how do you know that you are being attacked? But if you look at it from a siloed point of view, you may not be able to get that correlated view. That's why it's very important to have your security tools integrated. The next is the fragmented experience. You will have multiple dashboards. So do you have dashboards for dashboards? Or you have a wiki page where you put all the 10, 20 dashboards, and you have to go through it to figure out which dashboard you need to go, right? So again, it's all the complicated experience. So that's why it's very important to have a very integrated view of even the ops point of view. As a site reliability engineers or network engineers, try to have a simplified view of your system and what is that we can do for that. Then your so if you're having threat hunting team, if you're having cybersecurity specialists like Marcin who are trying to look through your logs, most of the systems stores the logs or the security logs for 30 days, because if you store more, it will cost you more. So you need to send to some other place where you data layer, an integrated data layer for you to do threat hunting on top of it. And then all these systems will have their own alerting mechanism. So you will get a PagerDuty alerts for the same event from various different tools. So think of like you are having 12 different systems, and then there is a vulnerability that your product is using. It will come from your scanning tool. It will come from your intrusion tool. It will come from some other tool that you are using. So it's just creates a lot of false positives. So what we need to do for that? The solution, you integrate Splunk. Again, this is an example. You can take Cisco Multicloud Defense, and you have PagerDuty. And by the way, it can be done in 10 minutes. It should not take you much. And I'll just show you some of the screenshots. All you need to do to integrate Cisco Multicloud Defense with Splunk is just you need to give the endpoint in the Cisco Multicloud Defense. And Cisco Multicloud Defense, by the way, is the product that is being used for intrusion detection. So think of like any tool that you are using. You need to have these integrations there, and think of like a data layer being present. And then for that, you can use Splunk. And if you're like us, you use programmatic interface like Terraform, just to ensure that this is the code that you need to do. So whichever tools that you are using as part of your security, try to figure out that they have the programmatic interfaces for that, so that you can send your all your security events from one tool to a central tool like Splunk. This is of the high-level view. If you see here, we have the Talos threat intelligence, and the Talos threat intelligence has got all the threats that continuously be happening. And then we have the multi-cloud defense edge that's connected to the Talos threat intelligence. And then you have the multi-cloud defense cloud. The key here is the multi-cloud defense cloud is just one part of the system, right? You may have another system, which is a software bill of materials. All the components that you have been using inside your software. There'll be another thing, which will be your third-party vulnerabilities. So the key here is send all those events. Let me be watchful. It's not send all those events, because if you try to send all of those things, then your cost will increase. But send only what is required, because we try to send initially, and then within 1 hour, I think we bombarded with 450 GB of memory, right? So don't send all the events. Send what is required. Most importantly, start with the critical or error-based one, or a high critical, then only send it to that. And the reason, because you send over here all these things, now you can have one PagerDuty attached to a group of events. Otherwise, you will have this PagerDuty alerts. If you're using PagerDuty, you have to attach it to here, here, and here. Then you will get repeated alerts, and no one can act on it. Suppose if an engineer is getting like 1,500 alerts, it's like useless, right? No one will do anything. So it's very important to get the alert that are actionable immediately. And then you can have the notification in the Webex. So what are the outcomes? Because we were able to do this, by the way, we didn't achieve this on day one, right? So we didn't make our mistakes. Then we realized that there is a dashboard for dashboard. There is a wiki page with a lot of dashboards. And for anything to debug, we have to go to 5 different systems. And then we have to go through the log. And then we started realizing, actually, this is so simple, but then we are so busy doing our regular work, and then we didn't pay attention to this. So that's why I want to share this as one of the practice. We found it to be useful. So if you're having a problem like us, multiple systems, fragmented dashboards, and the data is spread across all these things, try to see if you can send it to a central data layer. And then the moment you send it to a central data layer, you can do a lot of like ML and AI techniques on top of it, and Splunk has got that. Then so far, touch wood, we have 0 indicators of compromise. So all the 3.1 million attack didn't materialize to get into anything. The most important thing is, because it's all in centralized place, we are able to get the notification, actionable notification is less than 60 seconds. so we can react fast. Suppose your memory is going up because of there is a DDoS attack, and then we can go and rate limit it, shift the workload to something else, or we can put in automation in place to react to those things. And this is two things. Watch out. As I told, don't send all the logs from your other systems to Splunk, because it is going to bombard. Begin with only error level logs. And then keep the storage to only 7 days, because all these logs, that security events that you have in multi-cloud defense or in some other systems, they are going to have it. So there is no point in having a lot of these things redundantly made available in the other systems as well. Okay, that's on the first side of the things, which we like integrate your tooling for security. Don't keep them fragmented for you to work effectively on that. The next one is embrace observability. So let's just see what challenges we face. We didn't have observability when we did GA release. So the first initial 5 months, whenever a production issue happens, we were not able to identify the root cause immediately. Where is the problem? So we will get an issue saying that search is slow. Is our search service slow? Is the third-party software that we use for search is slow? Or are we getting a DDoS attack? Or is there a bug? So you cannot figure out all these things. So you have to go, and the infrastructure guy will look at infrastructure, a dev guy will look at the bug. So everyone will be looking at their own thing, but we are not able to collectively figure out where the root cause was. What part of the system is having the issue? And it took us at least like 10 to 12 hours for every production issue for us to identify this could be the problem initially, because we didn't use observability. And even before, and another thing, even before the production issue happens, we have no way to figure out which part of the system may fail in future. Again, the first 5 months was very, very difficult for us once we did the GA. Then where we want to go from what we are currently been practicing. So we want to understand at any point in time, we should have a system. And if I go to the system, it should say what database queries are slow. It should tell me that this is the database query that is slow. And who is the owner of the database query? It should say this is the microservice that is slow. And you made a change, you deploy it into production, and your system should be able to tell this new change has caused your production system to go 35% slower than what it was before. That means the new change has caused a problem, then you are able to revert back. What are all the dependencies for the service? Is it problem with the current service I deployed, or it is problem with the service, other services which are there? So that's the expected state we want to go. And for that, we have to make Cisco U observable. What does observable means? At any point in time, especially in a distributed system, when there are 74 microservices, 54 AWS services, and you have the security tools like Cisco Multicloud Defense and Splunk, you're talking about a plethora of services. So you should know what is working in the system. That can come from logs. But the logs cannot be in a fragmented way. They have to be in a centralized way, which we already saw. But the second one is most important. What is the work currently happening? If you take a user request, which part of the system are participating in the user request, and what is happening inside that? And how well they are performing, which is the metrics. And you can do this through a method called the instrumentation. This is our typical architecture in Cisco U. So we have a client, which is a front end. Most of the applications will be like this. In a distributed computing in a cloud-native application. You have an EKS service layer in a Kubernetes. We have the microservices. And then you have a data tier, which is a database. And then you will have an event-driven system. Now, if a request comes from the user, how can it trace the path all the way here? And that's what instrumentation is. It will look something like that. A trace is the start of the request to the path it takes, the entire path it takes all the way to the DB and what it returns back. And a span is what are all the operations that happens in this trace. So if you are able to trace this path for every request that you send, and you have the spans and you have the subspans, and you are able to instrument the code like that, the advantage you will get is you will be able to know when you are identifying your search is slow, you can go to the search service and look through the timeline segmentation. I'll show a screenshot of it, and that will give you an idea what you need to do in order for you to identify the problem. Or you can even look at it proactively, which are the areas of the system that can error out in the future. So how do you do this? So from the front-end UI, have you heard about RUM, or real user monitoring? Okay, there are two important techniques in observability. One is called the real user monitoring, or RUM. Another one is called distributed tracing. So what you need to do in the front-end UI, you inject actually something called a trace ID. It's sort of like a tag. You punch it in. So whenever in your UI code, when the person is making a request, you punch the trace ID there, and ensure that the trace ID travels all the way to your services across the board, from the infrastructure component to the application component, and all the way, and whatever the response comes back. So you will have the path. It's something like in the network we have a trace route. It is the same level, but it's sort of like in the microservices world. And then you transmit the client-side trace segment to the service tier. So if you go here, this is your browser. You inject the trace ID, and then you take it all the way to every path that particular request goes. If it is a search, it will go to the front end, it will go to the ALB, it will go to the microservice, and then the search component. And then it will get the response back. And then on the microservice side, which is on the backend side, you continue using the trace ID, and then you use the request header in your request header. So everywhere the HTTP request header is there, you just put the trace ID, and then it can go all the way. Because we are using Golang, it's a language. You heard about Golang? Yeah. So Golang doesn't have automated instrumentation. So many of the other languages has got automated instrumentation. We have to manually instrument it, but there are some advantages with manual instrumentation. You have to do something called a context propagation. So typically you write a well-defined good programming in Golang. So every method should have something called a context, and then you propagate the context all along the way. From method A, it's calling method B, then you pass the context, something like a session object in Java. It's not similar, but something like that. That's how the Golang dialect is. Then all trace segments captured and sent from the application to the collector. So the entire thing will look something like this. Okay. For this, we use an SDK called OpenTelemetry. The advantage with using OpenTelemetry is initially we used AWS X-Ray, and then after Splunk got acquired, now we can all we need to do was just one change, configuration change. Instead of sending to AWS X-Ray, you send it to Splunk, because OpenTelemetry is an open standard that most of the observability components uses. So I will recommend you to use OpenTelemetry than to any vendor-specific one if you're starting with observability. Then we built the framework from ground up. We went and took some of the open source components which are there, and we ended up having issues. And by the way, to write something like this, it will take just 40 lines of code, nothing more than that. But if you take something which is an open source, you take it, it will have a lot of issues. It may not fit into your thing. So based on our experience, my recommendation is if you're starting with observability and you're using Golang, just write what is the basic minimum required. And I'll tell you what one of the things that we do is, instead of doing this instrumentation in every file or in every method, you try to abstract it like a library and import that library as part of your code. And then when you write the library, these are the 6 important items that your library should have. And each one of these items which I mentioned is 3 to 4 lines of code. If you're interested, you can connect with us after this session. We can share with you some of these things, or we can even connect afterwards. So one is, how do you do the initialization of your observability? And how do you do the graceful shutdown? Because if you don't do the graceful shutdown, when your pod, because if you're running in a Kubernetes, the pod is supposed to go down, and then it will come up in some other place, because auto-scaling will happen. And if you don't do graceful shutdown, it will cause problems. Your observability will create issues within your system. So you need to ensure that you do initialization and do graceful shutdown, and you do the context propagation, because with context propagation, you will be able to take the metadata associated to the method, and also what trace ID you are able to propagate it all along the way. Then log and trace correlation. You may already have a log. Now you are doing traces. So both these things should again be correlating. Otherwise, your logging system will be separate, your tracing system will be separate. Try to do the correlation between the both. For that, wherever you are logging, use the same trace ID, and wherever you are using the trace, use the same trace ID, so that you can take the trace ID from here, go to your logging, and search for it, and see what has really happened as a problem. Then you do automatic resource detectors. These are something that's available within Golang. So if you're running it in Kubernetes, it can say, oh, this is, by the way, this trace is coming from a Kubernetes pod. This trace is coming from ALB. So these automatic resource detectors are there as part of OpenTelemetry. Leverage that, and then use your library configurations. This is mostly for when you are collecting these traces, try to not to collect for all the happy path items, because you'll be bombarded with so many traces. So try to do sampling for happy path, and for negative path, try to get all the things. Yeah. And this is our deployment architecture. So you have the OTel SDK, the collector, and then each of the pod will have its own collector, and it sends to the central collector. So the change which we had before when we are using AWS X-Ray, that's called the A-dot collector. And now when we switch to Splunk, we just use Splunk OTel collector. That's it. Otherwise, all the things, rest of the things works the same way. This is how the trace visualization will look like. And the advantage is if I get an issue saying, hey, your search is slow, I can go here and figure out which part of the flow I'm in, and what is the response time, and why it is slow. And I did not even get a problem. I can constantly look through this, because I can have something like a timeline. And if I have any of this segment status failure, there's a possibility that I'm going to get a production issue in 1 hour, 2 hours, or 3 hours down the line. This is the drill down, like how you can drill down deep inside it. And the outcomes, you reduce your debugging time. I told previously we were using like 10 to 12 hours time. And after putting it here, we used to take roughly somewhere between 8 to 15 minutes, because you can go through here, drill down that, and figure out where the problem is. You can take the trace ID, go to your logging system, figure out the logs. To a large extent, we will be able to identify the problem. Because of this, we reduce the SLA breaches. And then when you do this, again, don't try to do it for all the methods, all your microservices, everything. We did that, and then you will get the visualization with 50 nodes, which is of no use. So do it for the most frequently used customer using part of your system. Maybe your payments, maybe your course launches, maybe something that is very, very important. Start with that. And then we prefer manual instrumentation over automated, because automated bombards the system with so many traces, and we don't know which traces is important, because it takes less time. It takes somewhere between an hour to instrument your end-to-end flow. If you have the library defined, if you have these best practices, what I told, it's not too much complex, but you have to do the design upfront correctly. So overall, operationalize the logs. If you're using security from multi-cloud defense, send it to Splunk, which means you do tool integration. Don't stop with that. Also do observability. It's significantly improved for us, and hopefully it will improve for you also. With that, thank you so much, and thanks for your time.
I think that we have a time for a question. So do you have any question? Come on, be brave. Oh, we have a brave person. So what's your question?
Do you by any chance provide an out-of-the-box profile in Splunk for Cisco Multicloud Defense?
Yeah, you mean the integration between Splunk and Multicloud Defense? Yeah, it's there. Yeah, if you have anything specific, we can connect. We'll be here. We can show you some of the things because we did a 4-hour long session yesterday. We can show part of it to you all if you are interested. Yeah.
Do we have, oh, the second brave person.
So the tracing information should be added from, let's say, a web application standpoint from the developers in the front end so that you can trace the request back to the back end. So there is no way to do this integration without modifying the application itself.
Let me repeat your question and see if I got it correct. Your question is without changing the code or instrumentation, is there a way that we can get the same thing? It's available. That's called agent-based instrumentation, where you, for example, programming languages like Java or Python has got that. Go is a little bit tricky language. It doesn't have agent-based instrumentation, but if you use Java or Python, it is available. It will do the instrumentation. The only challenge which we see when that automated instrumentation happens, it will not give you what you are looking for. It will say this method call this method call this method. But it is like, it's good. If you don't have anything, it's good. But it will not, you're not able to pinpoint, oh, here is the problem. So that's why we prefer to manually instrument it, because you say method A is calling method B. By the way, method A is, the context is 1, 2, 3, 4. And I'm passing this SQL parameter so that when you look at it, click it, you can see the SQL query. So it's just preferential. If it works for you to do automated, maybe try with that.
The main issue is that doing in a manual way, there is a big overhead that I can see to go through everything and add the manual customization everywhere. So that could be a big issue.
Correct. Because you have to manually change it. There is quality issues that are born. That's one of the things why we captured those things as a library. So the code actually is one line he has to do. But actually, you know what? Today, you can actually develop a prompt. Even he need not do it. You can say, here's the context, here's the library, here's the method, and give it to a prompt, your approved LLM, and it can give you a generated code. Okay. Thank you so much. We'll be here if you have any questions.
Thank you.
Yeah, feel free to reach out. Thank you again. Thank you. Have a nice day. Bye.
Oh. Yeah, no, I mean, you can, I'm pretty loud. I'm just going to banter for a little bit. We don't need to start right now. You can have the mic on, you can have them off. Pretty sure the audience will be like, just keep his talking to a minimum, please. Helps if you plug in your laptop. Everyone's going to learn something. And you guys are going to get the unvarnished bit of me because it has been an excruciating ordeal getting here. I literally landed like 3 hours ago from the US, so I'm a little jet lagged. I've been running on coffee and very little sleep, so if nothing else, the fact that I will be able to do this presentation and show you how easy this is to use in my state right now, it really is that easy. But I do apologize if I stumble over my words because, you know, sleep deprivation is fun. I'll wait till the 30 because we're going to be streaming this. I don't want this to get cut off. So bear with me until the 30 after, and then we will kick this off. All right. Emma, we good? Sweet. All right. Thank you all for joining. If you are wondering why I have this incredible smile on my face, it's because this presentation actually started off as, I don't want to call it a throwaway, but it was something that I put out there for funsies. Hey, let's talk about this. I use this every day. Let's see how many people in the networking industry actually want to know about a 30-year-old text editor. And every single time I have done this, I've had people standing around. So I'm going to continue to do it, but it makes me smile every time. I promise I didn't do that one, though. So for those of you who don't know me, my name is Quinn Snyder. I'm a technical advocate with Cisco Learning Certifications. I'm a Unix neckbeard, and I am here to teach you a little bit about VI, or more importantly, Vim. And it is easier to use than you think. So we're going to talk a little bit about why you would use it, what the drawbacks of our modern-day WYSIWYG editors are, and then I'm going to walk you through an actual hands-on demo and provide some sample code. And you actually get to see the keystrokes that I'm doing while I'm doing this, so you can see that there is actually nothing up my sleeve for those who watched Rocky and Bullwinkle growing up. I don't know if there's a Webex space that's enabled for this session specifically. You can find me. It's at qsnyder@cisco.com or at qsnyder on social media. And if you have any questions, I will be able to answer them there. So like I said, we're going to talk about why do we do Vim, talk about some defaults, how to navigate, search, and replace inside of VI, talk about modes of operation, and then finally the cut, copy, and paste routine that we go through with VI. And that kind of gets you, you'll be able to not throw your computer away in anger if you have to use it. You're not going to be a VI expert, but this is enough to get you through those times when you do need to use it so you can actually accomplish the tasks you need to and not have to worry about, well, like I have to edit the file and FTP it over and wait and do that whole song and dance. You'll actually be able to use VI natively from the terminal. So, excuse me. If you don't know or you have not seen these yet, Cisco U is our learning platform, and I actually wrote 2 tutorials on using VI that are on Cisco U. For those of you who don't know, Cisco U has a variety of different tiers. However, our tutorials, the products that myself and the other technical advocates design and write, are free in perpetuity. So there's about 115-ish tutorials that we put out so far. covering everything from things like VI, Splunk, AI, networking, CCNA, CCNP level topics. We have security, we have some wireless coming. So all those will be free in perpetuity. However, those 2 tutorials are kind of the basis for how I built this presentation. So you can take a picture of that, go to u.cisco.com, and you'll be able to grow your Vim knowledge. So why do we use this at all? So Vim, or VI improved, has been a part of nearly every Unix-based install for as long as I can remember, and even then before that. So if you even installed some of the most, excuse me, basic Unix-based OSs, so that's your Red Hats, your Ubuntus, your Debians. Dating myself, you went to Slackware, if you were in Mandrake, if you went to Mandriva, if you did, there's others that were out there, my mind is blanking. Everything had VI as part of it. Now that also includes all of your modern Windows subsystem for Linux installation. So for those of you who run a Windows laptop and you use WSL, most importantly WSL2 because it's actually a VM running under Hyper-V, you will also have access to VI. So you can learn without having to install weird packages or deal with a GVim or anything like that. So you can use it on pretty much every installation that you have. It's simple enough to learn for basic editing, and by the end of this presentation, you will believe me on that. A lot of people say, well, I'm a Nano or Pico guy or gal. That often requires a package installation. Now, in a previous life, before I came to Cisco, I worked in secure government, both state and federal, where we couldn't have installation packages outside of an installation. It's called the STIG guide in the US. Anything that was a non-standard package had to be approved. If it wasn't approved, it wasn't going to work. Another regulatory or heavily regulated industries, healthcare, utilities, finance, a lot of times that doesn't fly either if you have like a Bastion or Jump Host there. So those Nano or Pico installations often require a package manager installation. How many of us use something like PyCharm or VS Code for our daily editing? We all know about the remote SSH tooling that's available with that. Okay, that's great, but it still requires a far-end download. So if you actually install and use the VS Code remote SSH plugin, you will see a .vs code folder that gets installed on your remote system. It has to download that package. Again, that may not be compatible with security requirements or things like that. Additionally, and this just came to me and I didn't put it on the list here, unfortunately. Well, actually, I did put it on here. If you've used Splunk at all, by default, Splunk installs itself into opt Splunk. You're not going to be able to install that remote code extension into those root directories. So if we're messing with configuration files to enable things like SSL certificates or modifying the actual Splunk configurations, we're not going to be able to do that using a remote code extension. We've got to do it natively on the system. Finally, your fingers get to stay on the keyboard, which is uber cool, right? How many people are impressed when you watch guys running C code in VI and you hear the clicking and stuff like that? So that's pretty cool there. And if nothing else, if you're using a Linux or Unix-based installation and you have to add yourself to the sudoers file. So a lot of installations will do that automatically for you now, but if they don't, to add yourself into sudo as an actual user, you have to use vi sudo. It's the only utility that can write to the sudoers file. Otherwise, you'll break the CRCs and it won't actually work. So if nothing else, you've got to use vi sudo. So let's get started. Now, like I said, I'm going to be doing a couple of things. I will have, if you want to take pictures of these, you can each individual time. There is a QR code which will take you to a PDF of this at the very end, I believe. If not, I will, that may be a problem. But I believe there's a QR code here. But I'm going to walk through a little bit of the setup here for each of these, and then we'll scroll over to the other side, and I'll demonstrate these things for you in an actual terminal window. So, setting the environment up. By default, VI, if you just run VI or Vim from the shell, it's going to leave a little bit to be desired inside of your window. So these are things that I like to have enabled just on the default side of things to make sure that when I run something or open a file with VI, that it's going to behave like I want. So first of all, this isn't as necessary for modern installations, but I do set BG equals dark. That changes the syntax highlighting so it's easier to read on dark terminals because I like dark mode. I don't hate my eyeballs that bad, so I want the colors to look good in a dark terminal. So it won't use like dark blues and dark greens. It'll use like light blues and yellows and pinks. A couple of things that are also really nice is set number and set relative number. So by default, when you launch VI, it will not have any line numbers on the left-hand side that we're used to in a lot of our modern code editors. If we do set number, that sets the line numbers from 1 all the way down to whatever line we're at in successive order. So it'll have an absolute reference of numbers. Relative number displays the line increments in relation to the current line. Now what I mean by that, and I'll show it in a second, is if I'm on line 3, it'll have a big 0 where I'm at. So I'll see I'm right there at line 3, and then above and below it'll have a 1 on either side, and then 2, and then 3, and then 4. So if I needed to jump up or down lines, it tells me how many lines I need to jump up or down if I need to move that way. You can set both of those, so I will usually set number, relative number inside of my defaults, and I'll get best of both worlds, and I'll show that in a second. Another thing that I like to turn on by default is cursor column. How many folks have tried to write a YAML file? How many folks have been bitten by the white space in your YAML file? If your hand's not up, you're lying. Set cursor column will enable a vertical line to show up on your terminal so you can see exactly where each character is in relation to all the other lines. So that way when we're worrying about Python indenting for whitespace or YAML files, it'll show up so we can see that very easily. And then finally, set HL search will highlight all of my search results when I do a search for it. By default, it doesn't do that. It'll highlight them in a yellow, and we'll see that here in a second. Now, when I invoke these from VI, I have to use the colon to activate command mode. So it'll be colon, then type set, and then BG equals dark, or number, relative number, etc. If I want those to be defaulted, like I want to, every time I run VI, I want those to be my defaults, I would store that in .vimrc, but omit the colon here, and I'll show you that in a second. So let's get moving here. So, on my keyboard here, and this is just a standard Ubuntu VM. So I'm going to start Vim. As you can see, by default, there's not a whole lot there. We see our tildes for our line numbers, etc. And if I were to just type some text, we see that there's no lines there. There's no line numbers there. So we'll do the set BG equals dark here. It won't do anything because I don't have any code there. If I had like Python code or something, you would see it there. Now let's do set relative number so you can see what I was talking about. So when we start VI, or when we enable relative number, we see a couple of things. First of all, we know that we're on line 3 based on that bottom left-hand corner there. So we know exactly where we are in terms of line number and position at all times based on that lower right-hand corner, position. When I enabled relative number, you can see that right now it says 0, 1, 2, and as I move up and down, it will change that numbering. What's that saying? Is it saying how many lines are off in relative position to where I'm at currently? If I enable set number, this is basically doing both things. Actually, let's do this. We'll punt. Okay. So in this case, I enabled set number, which will turn on relative number and number together. So you can see now I have an absolute reference of my line. So I'm on line 3, or line 2, or line 1. But you can see that it's going to move, and I get relative numbers above and below it. I like to have that enabled so I know how many lines I need to move, but you can just turn on number if you wanted to. So if I wanted to quit here, and start over. If I just turn on set number, you can see that I just have line numbers there. So we can either enable number or relative number or combine them. So for this, I'll turn that on, just so you can see it as well. Now, the other thing I talked about was set cursor column. So now, this right here makes it worth it. Like this is very helpful. So my highlighted cursor is there, but I have a line that draws across the bar of the lines of text as I move over. And then finally, I'm going to set HL search. And we'll see how that plays into what that means in a couple of slides. So right there, we have some nice defaults. We have some line numbers. We'll have some highlighting. We'll have the cursor column. We'll have the search results being shown up. So this is how I like my VI. You can enable those, and I'll show what the VimRC would look like in a second after we get through here. So those are my defaults that I like to have. So basic navigation. The other thing that people run across when they're navigating is you see a lot of VI tutorials, and they say, oh, you've got to use H, J, K, and L keys to move up, down, left, and right. I appreciate being a VI purist. However, you don't have to do that. Arrow keys are acceptable. So I don't know if you noticed that when I was moving across my keyboard here, as I'm moving, you can see, it's kind of hard to read, but if you look over at the keyboard over on the right-hand side, you'll see that I'm actually pressing the arrow key. So I'm just moving with arrow keys there. There's nothing wrong with that. It's completely supported inside of a modern VI session. Another important thing is we can have numbers to augment the amount of movement. So what I mean by that is if we need to jump over or jump, when I said if I need to move down or up several different lines, if I was to type 3 and then arrow up, I would move up 3 lines. If I was to do 4 right arrow, I would move over 4 characters. So we can augment the number of lines or characters we need to move, or really anything within VI by prefixing it with a number. Some handy navigation is 0 and $. 0 moves you to the beginning of the line. $sign will move you to the end of the line. So real handy to move back and forth and append things. We can move by words, B and W, or capital B and capital W. One of the common things that VI does is it if you have a lowercase and a capital letter, the capital will augment the behavior of the lowercase in some way. In this case, if I say W, lowercase w, that will move me by a word. Words are delineated by white space. However, it will also interpret punctuation as being a new word. Capital W says we're just going to move on white space boundaries. It doesn't matter what's in the middle. And I'll show that in a second. So like IP addresses. If I have 192.168.1.1, it would be 192 is a word, dot is a word, et cetera, et cetera. If I do capital W, it'll move over the entire IP address. So you can move that way. Another common thing to use is colon number. So how many have tried to SSH into a commonly changing lab device? You reuse IPs a lot. And when you SSH into the device, it says we can't connect because of the SSH keys don't match. Delete it from known hosts. Run into that issue before? Okay. If you've noticed, it says on line 122, we have that duplicate key, right? So if you were to VI into .ssh known hosts, do colon 122, that will take you right to that line, and then you can delete it from there. Double D will delete, and that's something I cover in another page. But you can very quickly navigate to wherever the problem is. So if your Python code says, hey, there's an error on line 57, colon 57 will take you right there. And the most important things, write and quit. So we can do colon W to write and then colon Q. You can do colon WQ together, but that is how you exit Vim without having to restart your computer. So if nothing else, you've learned how to write and exit Vim. So I will show some of these things here. So right now you can see I'm on line 7. Because I have relative number shown, if I need to go up 4 lines, I can type 4 and then up arrow, and it will take me right to that 4 lines up, or line 3. Now, if you notice something, it moved me to the very end of the line because that's where I was at the very end of line 7. VI does not wrap around wrap around lines. So like in a lot of text editors, you can arrow over to the end, and then it will take you to the beginning of the line and move over. VI interprets every line individually. So if I'm in the middle of a line here, actually if I'm at the end of a line, and move down, it will take me to the exact position where I was. It won't take me to the end there, but I cannot mouse over and move to the next line. Sorry, arrow over, not mouse over. So that's where that 0 and $ navigation becomes really handy. Because if I need to move to the beginning of the line, you can watch the 0 key. I move to the beginning there. If I move to the end of the line, I can do Shift 4. It will take me to the end of that line. So very handy ways to move back and forth across those lines because, again, VI is not going to do it for you. If I wanted to jump exactly, so I'm on line 5. If I wanted to go to line 3, I could do :3, and it will take me right to the beginning of that line. So again, that's how you navigate using the line delineation there. Oh, and then just to show you words here, let me do it at the very end here. I'll go to the end of this line, and okay. So just to illustrate my point of what I was talking about before, if I type W, it's going to move me across words. But you see how it caught that exclamation point. If I do B, it'll move back, but it does the same thing. It will catch that exclamation point, that punctuation as a word. If I use Shift W, it will skip across that word or that punctuation mark. So again, that's handy if we're dealing with things like IP addresses, brackets, braces, those kinds of things in our code. We want to move across that. We don't want to catch that in our skipping. Or just really quick back of napkin math, I need to move over 5, if I want to go back 5 words, I can do 5 capital B, and it will move me back 5 words. I don't have to worry about that exclamation point. So it's a real quick way to skip back and forth and not have to worry about that punctuation there. Sweet. Now, modes of operation. You probably saw me do a couple of different things there. VI is a little bit different in that we have different modes of operation because we only have our keyboard, right? So, why remember one set of keystrokes so you can remember 3? When you open VI by default, you're in what's called normal mode. Nothing is shown at the bottom. That's where you can enter all of those commands to navigate, to move, etc. So that's kind of like your basic mode of operation for navigation. Nothing is indicated on screen, and the text, any navigation occurs there. You'll see insert mode, and I'll show you what that looks like in a second. That's where we add net new text. So if we want to add something to what we see on the screen, we have to be in insert mode. And there's a variety of ways that you can get there, because why not? There's insert, there's append, there's change. So anytime you see the Cody-looking things there, that means you can actually type that on screen and it will move you into that mode. They all do slightly different ways of getting the text in there, but just I for insert. And you'll see that show up down here in the lower left-hand corner of your screen when you enter that mode. Now, since we don't have a mouse to use, we have to find a different way to select text for manipulation. If we wanted to copy lines or copy characters, delete certain things, that's where we use visual mode. Visual mode is used for text selection and manipulation. If we do, again, that modification of behavior, lowercase v, that puts us in visual mode. And you'll see that down here on the bottom screen as well, say visual. That's where we can select individual characters. So we can use our arrow keys, go over, go down, etc. We can highlight individual characters or collections of characters. Capital V will place you in visual line mode. And if I do cap V, you'll see visual line here on the bottom. That means that we're going to highlight text, but we're going to do so in line chunks. So I can't move in between, capture half a line. I'm going to capture the entire line if I select it. Both those are how we select things for cut and copy actions. And to get out of those modes, whether we're in insert or visual, we use escape to return back to normal. So just to show that here. So right now we're in normal mode. That's why all my commands are working. Nothing is denoted on the screen there. But if I wanted to add some text, I hit I. Oops. Just to show you. Got to make sure that keyboard's up. We hit I. Now we see insert. That insert mode said as add our character. We can now type things here. Okay? So we have that text there. If we hit escape, we're back into normal mode, and we can see that it's disappeared. Visual mode, if I do V, it says visual down here. And as I move my as I move my cursor over, I'm going to highlight those individual lines. If I move down, it will capture the beginning. This is the one thing where it will wrap around the text boundaries there. So it'll highlight each of those lines up to my cursor point. So if I wanted to delete that text or copy it, that's how I would select that text in order to do it. Once I have it selected, this is where I use my commands if I wanted to cut and copy. I don't want to get ahead of myself. I'll show that here in a second. But to get out of there, I will do escape, and I'll disappear. If I do Shift-V, it says visual line. So it actually denotes which mode I'm in. So you're not confused, am I in visual line or visual mode? But you can see that as I move up, it's selecting the whole line, and not just because I'm at the end of the line there. If I go up, it's still going to select the entire line. So that's really handy if we want to cut blocks of text and move them around. We use visual line for that. There is a third mode that you'll see. It's called visual block mode. Kind of an advanced technique. You use that for like multi-cursor editing and things like that. So I'll use that in my if I want to comment a bunch of stuff or do whatever, I'll use that. But for all intents and purposes, visual and visual line mode are really all you'll need. Oh, and just to kind of show you the difference here while I'm here. The two big ones that you'll use to enter insert mode are I and A for insert and append. If I do I, you can see that's going to put it in before the cursor. If I have that same piece there and hit append, it moves my cursor one over and then adds text there. Just a real, it's not important to know, like enough to use one versus the other most of the time, but there are times where I will use that just to save an extra keystroke or two because that's the whole fun of using VI. Okay, finding and replacing. This is probably the most confusing part that I will cover today. For most of what you'll use, you just need to use the find, the searching. So to search for text, you just type in normal mode, you'll type / and then whatever you want to search for, the string character. Because I have highlight search turned on, it will show you all of the different instances that it will find. To move between them, you can use N to move top to bottom. Capital N will move you bottom to top in your search results. That's where I like to have that highlight search enabled because it will highlight all those instances for me so I know exactly where I'm going. And it will actually show you if you go to the top of if you're searching, you start at the top of a file and you search for something and you hit N to go to the bottom, it will actually show finish searching continuing again from the top. So it will let you know when it's wrapped around that entire file. Now by default, searching in VI is case sensitive, so you need to end it with \C to make it insensitive. You can enable that to be default, but for a default installation of VI, searching is case sensitive. So I want to cover that real quick. Let's see here. Let me add in some text here. Hello, and let me go to the bottom here. Just to show you what's going on. Okay, so if I want to search for hello, / hello, and hit enter. We've now highlighted 4 instances of that word. It's going to move to the top. Well, I was at the bottom, so search hit the bottom, continue at the top, move me to there. If I hit N, it will move me to the beginning of each instance, and then when I go to the bottom, it'll say continuing and wrap around. If I do Shift N, you can see it's moving up like that. So that's how you would move between those instances. Now, if I do / hello, we're not going to find anything because it's case sensitive by default. So that's, if you ever talk to me, more often than not, like in a chat, I'm usually using lowercase because I don't want to remember did I capitalize something or not. Bad habits die hard. But if I do / hello \C, now I'm going to find all 4 of those instances there because I've turned on case insensitivity. So now, let me go to the bottom here and escape and append. I want to do one other thing here. So, if we want to replace text in a file, this is fun. So :s, search for what we're, :s/ what we want to find and what we want to replace it with. Now, if we type it just like that, that's the first line instance. So the first instance in every line will be found, the first instance in the current line that you're on will be found and replaced with that. If you append a /g at the end, that will affect every instance in that line. But it will not move beyond that line. If you want to search the entire document, instead of using :s, you use %s, and that will replace everything in the file. So, and again, case, if you append a /i, so if you do like GI, it will make it case insensitive. C will require confirmation, so it's like, do you want to replace everything? You do a /c to require that confirmation. So you can build your own adventure just by appending tags at the very end there. But I want to show you this real quick to show you what I mean. So let's replace the hello. And if I do :s hello with hello, it just replaced that first instance. I'm on line 14, it just replaced that first one. Now if I do :s hello g, again, I'm still on line 14. It will change every instance in that line. If I want to change everything else here, %s hello, and if you want to affect every instance in the entire document, you do need to do that G, so it's not just hitting the first instance of every line. And now we've changed everything there. Real quick on that. Yeah, cut, copy, paste. We know we're running short on time. D is delete. You also use X. DD deletes the whole line. Copy is called yank. You can do YY for the whole line. Paste is normal. The one thing I do want to show you is the undo. Because we've all made a change in VI. We want to make sure we can undo it. All it takes is the U key. And it's not just a one-time thing. I can keep going back and back for every change I made. It saves all these in what's called a register. So all those changes are saved, so we can go back across lots of different changes if we wanted to. Just to show you kind of what's going on, I could do YY to yank something and then paste it. I could do a double D to delete that line. If I wanted to delete 2 characters, I would do 2X. What's going on there? There we go, 2X. To delete something, I can undo with U, et cetera, et cetera. So we can cut, copy, and paste that way. Wrapping up. If you retain nothing else, this is the screenshot to take a picture of. I to enter to write mode, escape to get out of it, right to save a file, Q to exit. Arrow keys, YY copies a line, DD cuts a line, X to delete a single character, P to paste, U to undo, :line, and /string to search. So hopefully, even in my jet-lagged and blurry state, we saw just how easy it was to use VI, at least for basic editing. The more you use it, the more you grow. I've been using VI as my daily driver text editor for about over a dozen years now. I do use VS Code for demos, but even that, I usually use VI bindings with it just because it's natural. It's really cool. You can impress your friends. And by the way, once you get into VI, your terminal can look really cool. And it looks like you're doing magic when you move stuff across with buffers and registers and things like that. So anyway, if nothing else, you've learned a little bit about VI. Appreciate your time. If you want to come find me to talk more about it, I'll be around the world, the Learning and Certifications Lounge. I have some more DevNet zones as well. You can find me on Twitter at QSnyder, qsnyder@cisco.com. Thank you for your time.
Can you guys hear me okay? Awesome. We'll go ahead and start in a few seconds here. Hopefully everybody's enjoying their first full day of Cisco Live, though. Hopefully you all didn't have to travel too far and all your travels were smooth. Just to quickly introduce myself, my name is Kyle Winters. I am based in Southern California in the United States. I am a technical advocate on the learning and certifications team, and I take a focus on security. I've worn many different hats over the years, whether it's solutions architecture, customer success, application security, all sorts of different roles. But today I want to talk to you all about hardening IT security environments, hardening IT environments, and taking a proactive approach to security. So just a little housekeeping. We do have a Webex app. You can join the room and ask questions there. That Webex room will be monitored until February 28th. So feel free to post questions. I'll post some slides and resources in there at the end of the week as well. So our agenda for today, we're going to start by covering the cybersecurity landscape and then give you an introduction on the Center for Internet Security, or CIS. We'll then dive into CIS controls as well as CIS benchmarks, explain what those are and how that can be a valuable resource for you as you work on hardening your IT systems. We'll end with some resources as well for you to help you along the way and set you up for success. So, to begin, let's talk about the cybersecurity landscape, and we'll start with a quote from Gartner. More than 85% of organizations will embrace a cloud-first principle by 2025, that's this year, and will not be able to fully execute on their digital strategies without the use of cloud-native architectures and technologies. So there's a big paradigm shift that's occurring as things move into the cloud space. There's also a new application paradigm that's unfolding as well. Companies want to be more agile. They want to do things at a quicker speed and velocity. They want to have more specificity and more visibility into what their systems are doing and how they're operating. They want to be able to scale these very quickly and effectively. And they also are building systems that are increasingly more complex as time goes on. There's new application architecture that's unfolded over the last decade as well. It's no longer a single pane of glass, a single server that's housing all your components. Nowadays, with things like containers and microservices, things are a lot more distributed. You might have your front end sitting in one container, a database in another, your billing services, all these different components sitting across different containers, having different IPs, communicating with each other through various ports and protocols. And that really makes the systems of today a bit more complex. To add to that as well, there's a rapidly accelerating application development process. It's no longer the days of waterfall where you would have these, up to 6-month development cycles, and things are shifting now to 2-week sprints, and with the introduction of artificial intelligence into the SDLC, it's moving even faster. All these components are becoming automated, and the need for security is prevalent in every single step of this as well too. Security is ultimately shifting left, and you need to be able to account for that and check for these different security risks and vulnerabilities at each step of the way. Really, with DevOps, it's really accelerating the process quite a bit, and there's a lot more things that you need to take into account as this process becomes more automated and more developer-focused and shifts further left. So the paradigm and the application architecture and all these different parts of the SDLC are shifting. But on top of that, threats are becoming more complex as well. They're leveraging all sorts of different tactics and techniques. This is a graphic here from the MITRE ATT&CK framework, and you can see that a typical attack is now leveraging many different phases of different tactics and techniques across that MITRE ATT&CK framework. It's becoming a lot more complex than it used to be back in the day. On top of that, it's also becoming more frequent too. This is just from a few years ago. You can see just a ton of high CVSS score type vulnerabilities that are occurring at any given point in time in the year. And if we take a look at it in aggregate here, you can see compared to 10 years ago, there's 5 times more CVEs being published each year. So the amount of vulnerabilities that are being discovered on a weekly basis is increasing significantly as well. These threats are also becoming more expensive too. And just the time that it takes with these different attack vectors and the increase in their sophistication, on average it takes 21 minutes from the time that credentials are discovered to when an attack is initiated. And the average cost of a breach in 2023 was $4.4 million. Now, you can reduce that cost a little bit if breaches are discovered within 200 days of that when they were essentially triggered. But the more complex your system becomes, the more costly those breaches are as well too, adding up to 1.44 million on average when those systems are more complex. So it's becoming more expensive, and the sad reality is that these cyber threats are really built upon avoidable mistakes. And just to give you a few examples here, 80% of cybersecurity breaches involve privileged credentials that somebody was able to access somewhere. 78% of those attacks are leveraging known CVEs as the initial attack vector. And on average, it takes 3 steps in an attack path to reach the crown jewel assets. Now, if we dive into that further, 70% of organizations have a Kubernetes API server that is publicly accessible. That's a lot. And 72% have at least one S3 bucket that has public read access attached to it. And 36% of organizations are keeping unencrypted secrets and PII in these cloud services. Now, probably the most shocking number of all is this last one here, how serious these misconfigurations are. And 99% of cloud breaches will have a root cause that is tied to a preventable misconfiguration. So this is a significant problem that the industry is seeing. Now, there are solutions for it, and one nonprofit organization that I want to talk about today is really here to help you with that, and that is the Center for Internet Security, also known as CIS. Their mission is very straightforward. It's to make the connected world a safer place by developing, validating, and promoting timely best practice solutions that help people, businesses, and governments protect themselves against pervasive cyber threats. And really, their vision is all about leading the global community to secure our ever-changing connected world. Now, I'm sure that's some marketing jargon on their part. What does that really mean? It's really a community-driven nonprofit that is responsible for what we're going to talk about today, the CIS controls and the CIS benchmarks. These are developed in a consensus-based process. It helps facilitate collaboration. It's really about setting you up and giving you the tools that you need to be successful and harden your IT systems effectively. So the first part of it that I want to talk to you about today is the CIS controls. And let's use a garden as an analogy. Now, we'll talk about the garden a little bit here in terms of CIS controls as well as benchmarks. Now, if you're growing plants, let's say in your garden, you know that you need a couple things. You need water, you need sunlight, you need fertile soil. Those are kind of large, general, descriptive things, and that's really kind of an analogy for the CIS controls. When we get into the CIS benchmarks, that's going to be the more prescriptive thing. Each plant obviously needs different amounts of sunlight, different amounts of water, different nutrients, and that's the benchmarks in a sense. But to start with the CIS controls, these are really prescriptive, prioritized, and a simplified set of best practices that you can use to strengthen your cybersecurity posture. It consists of 18 overarching measures, and they're very straightforward. They're very tactical, a lot of these. It'll be a single line in a sense that says, do this or do that. And we'll give you some examples here, but thousands of cybersecurity practitioners from around the world are leveraging these today. And just to give you an example of one, Harley Parks here, who's a director at ACD, said, the CIS controls take the background and knowledge of cybersecurity experts literally around the world and help focus efforts on things that are of most value, directly impacting the adversaries and challenges we face today on our networks. So, with CIS controls, really what you can do is simplify your approach to threat protection. You can comply with a lot of industry standards and regulations across the board, improve your overall cyber hygiene, take these actions, or take these steps and transform them into actions, and in some cases abide by different laws that exist as well too. And to give you an idea of some of those regulations, maybe some of these resonate with you and your businesses. It covers things like GDPR as an example, PCI compliance, SOC 2, some that are specific to governments that you may be familiar with here as well. So if you are in a space where you're focused on any of these different types of regulations, this is going to be a very valuable tip for you and a very valuable tool for you to leverage as well. So really, these CIS controls, they're important because they take a risk-based approach and help you essentially mitigate these things one at a time. It's highly scalable as well, and it's all about measured outcomes. And they give you a lot of good information to help you along the way. And we'll dive into that in a second, but just to give you an idea of the structure of each CIS control, there'll be an overview, why that control is important. So we'll go into a description as to why the industry has decided that you need this type of control. It'll talk about procedures and tools that you can leverage along the way to help you accomplish that control, and give you descriptions on the different safeguards that are part of it as well. So I mentioned there's 18 different controls, and in each side of those, there's different safeguards that apply as well too. There's also another concept related to CIS controls, and that is implementation groups. And this is a valuable way for you, based off of your organization, to figure out what the scope is that you want to focus on for your CIS controls. So IG1 is Implementation Group 1. That is, if you're a small organization or you're just getting started, you have a small cybersecurity practice, these are essential for basic cybersecurity hygiene and a great place to start. It covers 56 safeguards on its own. And as you kind of go down to IG3, the scale and scope of it becomes greater as well. So if you're a large enterprise, and you have a lot of different systems, a lot of different customers, maybe you're a government as well too, IG3 is a great place to focus because that is inclusive of IG1 and IG2 as well. So IG2, as an example, has 74 safeguards unique to it, and IG3 has 23. But if you're doing IG3, you're also doing IG1 and IG2 as well. So that's 153 total safeguards for your organization to implement. Now, the 18 different controls, you can see them up here. And as I mentioned, they're kind of big, grand ideas, so to say. So it could be something like inventory and control of enterprise assets. It could be something like access control management. But inside of each one of these, there's individual safeguards for you to try to accomplish as well. And let's just pull one here. Let's do number 6, access control management. It might be a little hard to see on the screen there, but I'll go ahead and zoom it in a little bit. Let's pick that one right there. You can see one of these safeguards here in particular, safeguard 6.3, require multi-factor authentication for externally exposed applications. So you can see this one is related to IG1, 2, and 3. The security function there is to protect, and it's to protect the asset type, which is users. And it'll give you a description as well of that safeguard and why it's important there. So obviously, I think for most cases, whether you're a small organization which has a scope of IG1 or a large enterprise, you want to ultimately accomplish this type of task. And it doesn't necessarily say how to do it. Like I said, it's kind of that more high-level idea of making sure that you accomplish this. So it's kind of up to you and how you want to run your organization, how you accomplish that. The ultimate goal, however, is, in this case, make sure that you have MFA enabled on those applications. And to give you an idea as well of the difference between the scope of IG1, 2, and 3, I've got 3 great examples here under the data protection control. If you're just focused on IG1, the level of scope might be as simple as encrypt data on end user devices, something that hopefully everybody here is already doing. Now IG2, for that more middle-size enterprise or company, it would be encrypt sensitive data in transit. Now, if you're going all the way to IG3, you're a large organization, their recommendation for this safeguard is deploy a data loss prevention solution. So you can see the scope gets more and more complex and more involved the higher implementation group level that you go. So this is just to give you an idea. Like I mentioned before, if you are a kind of organization that wants to focus on implementation group 3, you do include all the things leading up to it. You can see that even that first one there says IG1, 2, and 3. So these can be very valuable steps. And just to give you an idea of some of the value that comes with it, even if you're just focused on IG1, it'll help you protect against 77% of malware that's out there today, 78% of ransomware, 86% of web application hacks, et cetera. But if you were to do all of them, all the way through to IG3, that increases even more significantly. if you're doing all the CIS safeguards, that's going to protect you from 94% of malware that's out there, 92% of ransomware attacks, 95% of targeted intrusion attempts as well. So as you can see, this can be a very valuable tool in hardening your systems and preventing your organization from malicious attacks. So if you're interested in completing these CIS controls, there are different tools that are available to you online. The first step I always recommend, though, is assessment and planning. You obviously want to make sure that you have the right resources, that you're focused on the right controls. And I highly recommend an incremental approach to this as well. You don't need to shake the ocean and boil it over and do every single thing at once. Focus on one control and one safeguard at a time and make sure that you get it right. And then once you feel confident in that, move on to the next one and have it be an incremental, iterative process. Now, there is a lot of documentation on these safeguards and these controls available online. You can go to the CIS website as well. There are different automated tools as well, such as CIS Cat Pro. And a big part of it as well, too, there's a lot of training and opportunities for you to learn about these controls and apply them today. So that's CIS controls in a nutshell. And as you can see, like I mentioned before, going back to that garden analogy, it's really kind of that more high level of, a plant in a garden, it needs water, it needs sunlight. These are the things it needs to be healthy. But like I mentioned, every plant is different and it has different needs. And that's where the CIS benchmarks come in. So we obviously have a lot of different systems out there today, whether they're different types of Linux servers, different types of Cisco devices, different types of cloud providers. And the reality is that a lot of these obviously come with default configurations, and those are largely built for convenience, ease of use, ease of deployment, but really they don't take security into account the way that they're released and put out on that initial default configuration as well. And if you don't change these default configurations and have security in mind, you could leave your system vulnerable to a lot of different cyber threat actors. So that's where CIS benchmarks come in. It's again, that community-developed security configuration recommendations for these different systems. It's those best practices that are very prescriptive and very direct. Each of these is mapped to those CIS controls. So by completing these CIS benchmarks, you're also completing the CIS controls as well for those different systems. They are covered for over 100 different vendors and technologies out there, whether, like I said, cloud providers, databases, desktop computers, different types of software, mobile devices. I'll show you a list of those here shortly, but these are very valuable. And to give you a quote here as well from Adam, he's a banking information security engineer. He said, "Without this resource, the hardening of our devices would have taken a lot longer and required many meetings between IT and security to debate which configuration settings to change and the impact that they could have. The CIS benchmarks provided the necessary information to alleviate many of the fears IT may have had with changing specific settings." So very compelling, very valuable resource. And as I mentioned before, these are built in a consensus-focused development process. So they have a community of thousands and thousands of engineers that are part of CIS. Some of you might be part of it today as well, too. And this community meets regularly. They engage other people outside of the community as well, and they come up with a consensus on what are the best practices for these different systems to make sure that they're secure. It's not just some person or bureaucrat or some guy up in a hill somewhere saying this is what you need to do. This is the community coming together and saying this is what we as a group have come to a consensus on and said is necessary to secure these systems. So we're going to dive into an example of a CIS benchmark here shortly, but to give you an idea of what's included in it, it'll have a description and a rationale as well that says why this is recommended. So you are kind of going into it with that understanding initially. It'll talk about the impact as well and what the benefit is of leveraging this benchmark. And then it'll give you actual steps on how to audit to see if this is in place already today, as well as what steps you need to remediate that so that way you can implement that and have it in place on your system. So these CIS benchmarks, they're available on the CIS website as a PDF, or if you're a CIS Secure Suite member, you can access it through their tools inside of there. But conveniently enough as well, there are CIS hardened images that have everything already ready to go for you too. So you can have an image of, let's say, Ubuntu as an example that has already been hardened for you and takes all of this work out so that way you are ready to go. To give you an idea as well of some of the different vendors that have CIS benchmarks in place, you can see they cover cloud providers like AWS and GCP as an example, desktop softwares including some of the different web browsers that are out there, mobile devices. Network devices, you might see a familiar name, second one down under network devices there, and different types of operating systems and server technologies as well too. So one I want to go into today that's obviously very common and very popular is Ubuntu. I think a lot of us here have used Ubuntu, and this is an example of some of the different benchmarks that exist for Ubuntu today. So you can see it covers things from the initial setup, services, network, host-based firewall, access control, and logging and auditing. And inside of each one of these, there's different areas of focus as well. I want to dive in a little bit more into category 5 there, access control. And let's take a look at what it recommends for configuring SSH server. So you can see inside of this one, there's 22 different steps that it recommends to ensure that that server is hardened when it comes to SSH. It can be anywhere from ensuring that the appropriate ciphers are configured, making sure that you're ignoring remote hosts when necessary, all sorts of different things. And to take a look closer at one of these, we're going to take a look at 5.1.20, ensure SSHD permit root login is disabled. Obviously, you don't want somebody to SSH in as a root user. That would not be advised. So taking a look at this actual benchmark from CIS, you can see it gives you a description of what it is. You know, the permit root login parameter should not be enabled. It should be set to default or prohibit password. And it gives you the rationale as to why that should be the case as well, too. Now, if we continue on and looking at this, it'll actually give you the necessary commands to audit and see if you have this enabled or not today. So you can go into your Ubuntu server, run that command, and if you get that, then that means you already have permit root login set to disabled. But if you see something else, you know now that you have some work to do, and it'll give you the necessary steps on top of that as well to remediate that. So in this case, it wants you to edit that particular file there, sshd_config, and change that permit root login setting to no. So these are obviously very prescriptive steps now and giving you the exact step-by-step that you need to implement this particular benchmark and harden that system. And like I mentioned earlier, they're all tied to specific CIS controls as well. So you can see in this particular case, this one is tied to CS control safeguard 5.4. And it'll also show you as well the MITRE attack mapping, where if somebody was to take advantage of this vulnerability, those are the different types of tactics that they would be leveraging to do that. So hopefully this was very useful for you. And I mentioned earlier that Cisco does have CIS benchmarks for some of its technology as well. You can see a list of that up there, whether it's firepower, firewall, iOS, ASA. Those benchmarks exist, and you can find those on the CIS website as well, and make sure that your Cisco technology is hardened and as secure as possible. So if you're interested in adopting these CIS benchmarks, start by taking an assessment and selecting which of these benchmarks are going to be relevant to your organization. There might be situations where a particular benchmark doesn't apply to your organization, and that's okay. These are best practices, but every organization is different, so do what makes sense for your organization. They are highly customizable. And once you've figured out which ones are of relevance to you guys, the process of implementing it is pretty straightforward, just following those instructions that are included with it. And there are various tools that exist out there. I mentioned CIS Cat Pro. That's a great tool to automate some of the assessment and implementation of CIS controls and benchmarks. There's all sorts of other tools as well that are available in a lot of documentation. Conveniently enough, Cisco also has a tool that's focused on this called Cisco Panoptica, which focuses on comprehensive code to cloud security. It covers a lot of different things, but a part of that as well is compliance monitoring, which also covers CIS benchmarks. So if you're not familiar with Panoptica and you haven't seen a demo of it, They should be over there, I believe, in the security zone, if I'm not mistaken. But just to give you a little taste of what comes with that CIS compliance tracking in Panoptica, you can see that we cover up there, you can see AWS CIS version 1.3 selected. So this is the necessary benchmarks auditing for AWS infrastructure, and it'll give you essentially the different breakdown of where you're compliant and following along with those benchmarks and where you're missing the mark, as well as prescriptive steps further on to do that and remediate that. So it's a very valuable tool. I highly recommend that you check it out. It can help you streamline a lot of this and continuously audit and monitor as systems are coming up throughout your organization. So hopefully this was a valuable session for you all. I really appreciate you joining me here today. In summary, we did cover a lot of these controls and benchmarks. Hopefully these are valuable to you. Just remember that there's 18 controls and a lot more benchmarks for over 100 different technologies, and those controls are mapped to the benchmarks as well. So when you're doing the benchmarks, you're also solving for the controls. If you're interested in learning more, I highly recommend that you check out the CIS website. I will post that in the Webex room later this week for you to check out. And feel free to begin implementing those CIS controls and benchmarks as well. I also recommend that you check out Cisco U. If you're not familiar with Cisco U, it's the name of the theater here. It's our premier learning platform that we have at Cisco. There's a ton of free tutorials that are available there. So I highly recommend that you check that out, as well as check out Panoptica and get a free demo of that as well too. So thank you all. I really appreciate it. As you're going through the week, feel free to fill out your session surveys. You fill out 4 of them, you get this awesome special limited edition Amsterdam only Cisco t-shirt here. So highly recommend your feedback. It's always appreciated. And as you enjoy the rest of your week here, feel free to check out the Cisco showcase for related demos, book a one-on-one with the Meet the Engineer. We have capture the flag exercises going on in the DevNet zone here as well too. So a lot of fun stuff, and I hope that you all take advantage of it, make the most of your week here in Amsterdam, and have a great time. And thank you all so much for attending today.
All right. Good afternoon. For anybody who flew over from the United States this morning, good very early morning, because I'm running on about 3 hours of sleep and a whole lot of caffeine, right? My name's Patrick Lloyd. I'm a senior solutions architect for Cisco Professional Services. I focus in segmentation. I'm a co-author of the book called Zero Trust Architectures, which you see on the top right-hand side there. I've been working with Cisco Professional Services for about 14 years now. 10 of that has been in security. And having conversations around what I'm going to talk about today is what I refer to as a segmented architecture. And a lot of times when we start these conversations off, it starts off something like this. If we can get to the right screen. Come on. Oh, there we go. Is, hey, Patrick, I have this architecture. And this architecture has a couple data centers, it has a branch, it may have a large administrative office, et cetera. And you know what? I have a really good feeling for what I want my segmentation strategy to be. And what I want my segmentation strategy to be is, well, I have these users over in this side of the architecture that I want to be able to access my database server. But if they wander over to this branch here, they shouldn't be able to access my database server. Well, then I have a different classification of users in that area that should access a different database server, as well as the people in this area. And oh, by the way, I have some IT users down here, and they need to be able to get to everything, including some of these application users. And I sit back and I stop and I say, wow, that sounds really complicated. Because, let's face it, when we're segmenting the network, we always have a really basic goal, right? We want to take a whole lot of unknowns, turn those unknowns into knowns, and kind of understand what the devices on our network look like, what the endpoints on our network look like, and eventually put them into groups and say, this is the permission that any given group has on my network. But what we started with was a very challenging and very complicated topology. And eventually, if you keep going down that route, what we kind of refer to as boiling the ocean, it starts to look a little bit like this. This is an actual customer matrix. When we implemented this customer matrix, it was for an IoT smart building where the customer had a ton of different IoT-based use cases, where they wanted the ability to change how electrochromic glass was lit up, whether it was light, whether it was dark, depending on the amount of sunlight that was hitting it. They had their Rainbird irrigation system, smart elevators, smart escalators, everything on their network. And this matrix ended up being 137 cells by 137 cells. How do you describe to your level 1 help desk engineers, hey, this user on this PC gets this policy versus this user on this PC gets this other policy? It becomes very challenging to operationalize. So we started having these conversations with customers, and we built an entire service around this. And the number one messaging that I want everybody to walk away with today is, your security journey is just that. It's a journey, it's not a destination. You're going to continue to improve upon your overall journey constantly. And you're probably going to start off with a few use cases, a few things that you have to segment. And that may very well be printers, ensuring that your user talks to your print servers but never talks to your printer directly. Ensure that your cameras, which will be the death of me, or your MRI machines for those in healthcare, will be the death of me because they need to talk peer-to-peer, which is the last thing that you want to see on your network. You want to see everything talk back to a management station, right? So essentially, what you'll do is you'll start to create these individual use cases that you can form your segmentation story around. Now, how do we get to that point? How do we get to the point where we can form that segmentation story, carve out those use cases, and essentially say, this use case here is something that's going to be successful to my business? Well, it's what I refer to as our mountain climber slide. And the mountain climber slide goes through a number of phases. Those number of phases essentially starts off with, first off, having a standardized architecture. It's still, to this day, I've been in the networking industry for the better part of 2 decades, really blows my mind that most organizations don't have a standardized network architecture. But what we found is the greatest benefit in a lot of these organizations is to now take all of your sites and classify them into what we refer to as t-shirt sizes. Small, medium, large, extra large, and try to build a standardized topology around that. Because the biggest challenge that you're going to run into in any segmentation journey is that one-off. It's that site that has a local server that sits off of the distribution switch that you're not authenticating anything on, but now anything can interact with. The second step of that is going to be consistent onboarding processes. We'll talk about that in just a minute, but the consistent onboarding processes is the other biggest pain point that we see with most of our customers. And then we work through what we refer to as the identity, the vulnerability management, the enforcement, and the analytic stages. Now, to start down this journey, the number one thing you need is a team. Because let's face it, network and security have 2 different viewpoints on how they approach a segmentation implementation. Your network team just wants to get users onto the network. They want to provide that connectivity. They're only caring about those switches and how that user accesses whatever they need to get to the business application that they need to access. Your security team is looking at what threats are present on that network, what capabilities, what types of endpoints should we allow onto the network based on our policy and governance. We also have our operations team, and our operations team is kind of caught in the middle of them, saying, hey teams, we just need to get this user on. We need to give them the capabilities that they need, and they're complaining to us, so please make our jobs easier. How can we get this user access to the applications that now drive the business and drive overall revenue? Now, I didn't use this quote in my first book. I'm probably going to use it in the second book. But policy is downstream from culture. When we start to talk about zero trust networks, we break it down into 5 different, what we refer to as capabilities in zero trust architectures. Those 5 different capabilities start with policy and governance. Now, policy and governance is the idea that I have a policy that can dictate what access I give a given user. If I don't have that policy, what happens? My VP calls my operations team and says, get this device on the network now, because it's what I refer to as executive bling. It's my new iPad, my new Surface Pro, my new IoT device that I bought off of eBay, and now I want on the network because it should have some level of connectivity. If your operations team is armed with a policy that says, here's what my onboarding process is, here's the types of endpoints that are allowed on the network, and here's what they have to go through to get onto my network, they can continue to help you secure your network from a policy and governance standpoint. The second aspect of that is identity. Now, I want to understand when it comes to identity, who is on my device, what device is it, what location, and what medium did it come in over. Now, I specifically want to understand all of that so that I can then understand how does this device behave? How does it interact with other devices on the network? Is it normal for me to see this IP security camera interact with other IP security cameras because it downloads the configuration from those other IP security cameras so I don't have to touch every one of those individual devices? Is it normal for me to take this MRI machine and see it interact with other MRI machines? Because the procedure is so long that if that MRI machine for some reason crashes, we want to back everything up to another one so we can move the patient from one MRI to the other and immediately start that procedure from where we left off. Are those normal behaviors? And that's what we really have to understand is what is the baseline normal behavior so that we can move into what we'd refer to as the enforcement stage. Now, the enforcement stage, this is what all of us know really, really well, right? This is what we've been building for years. This is the idea that we can put firewalls anywhere in our network and prevent two VLANs from interacting with one another. This is where we can put a downloadable ACL or a dynamic VLAN on an endpoint and prevent it from interacting with other devices on the network. But how many of you have tried to operationalize VLANs as a sole segmentation mechanism? 1,000 VLANs out there, 3,000 VLANs out there. I have customers who try to do it. It gets even worse when you start getting into private VLANs. The private VLANs are the fun ones because now you have to figure out what VLAN is this assigned to and then what sub-VLAN to that VLAN is this assigned to. Well, within the enforcement mechanism, now we can kind of talk about, okay, how do we actually implement enforcement? And that's typically what my customers are asking about, is where do I start enforcement? And I pose the question back to most of my customers to that extent. And I'll ask, okay, what's most important to you? Because I can't dictate where you start enforcement. It really comes down to what the crown jewels of your network or what the weakest areas of your network where you think you need to improve are so that you can implement there first. Now, being a campus guy, focusing on ICE and TrustSec and StealthWatch and those sorts of technologies, I'm typically going to advocate starting over here in the campus. And that's because, let's face it, your physical data centers are typically physically secured as well. Some sort of fingerprint readers, iris readers, man traps, however you go about physically securing those data centers, that's pretty easy to say, okay, we can develop some sort of onboarding process so that someone can't just walk into the data center or a very few number of people can walk into the data center and plug in some sort of new workload. Now with virtualization, that does get challenging, right? With AWS workloads and Azure workloads and things like that, because anybody with a credit card can spin one up and connect it to my corporate workloads. But generally for the physical data center, I can secure that very easily with a physical boundary. In the campus, if you have branches, if you have hospitals, if you have retail branches, small stores, et cetera, and you have an exposed port, how many times have you seen someone come in and say, I just need internet access for 5 minutes and plug into a wall? Our IR teams at Cisco love that. We send red teams in all the time and they say, hey, I just want to use your internet for 5 minutes, and they plug into the wall, and next thing you know, they have access to the crown jewels of the overall network. So I'll typically advocate for starting here on the campus side. It's also where we have really strong tools to give us the capability to understand what's out there, understand that who, what, where, when, how. The first step of that, going back to the point that I was making before, is establishing your onboarding process. Because now, regardless of how I do my onboarding process, now my corporate endpoints, they're pretty easy. I can use, whether it's Meraki Systems Manager, System Center Configuration Manager, Microsoft Azure, AirWatch, Jamf, whatever. I can onboard those, and I can make sure that I have consistent configurations pushed down to those so that they present their credentials, their certificate, some way to identify. I've even had customers push unique DHCP attributes to their endpoints to identify them as a corporate endpoint. Where it really becomes challenging is now with my IoT devices. Because now I have those IoT devices. Does anybody in the audience have a specific onboarding process that they use for IoT devices? I want to talk to you afterwards. Because notice I have one person in the audience that has an IoT onboarding process. Now, typically what I see is ServiceNow. And then you can utilize Identity Services Engine with PX Grid Direct to pull from ServiceNow and pull in MAC addresses, or pull from LDAP and utilize that as part of your authentication mechanism. And the great thing about ServiceNow is you can set a field in ServiceNow that says, hey, if these fields aren't filled out, it's a false, and if it's a false, I don't allow it onto the network. I deny it access from the network with ICE. But typically, this is the biggest challenge that we see with customers is they can plug in whatever they want in the campus, and they haven't followed that onboarding process. And that's why it becomes so much more important. Now, once we have that onboarding process, then we can force every device out there to tell us what it is. we can try to get it to tell us, who is it, on what device? And now someone here is going to stop me and say, well, IoT devices aren't going to have a user. That tells me just as much as if it did. Because if I have a camera out there that's trying to present a username, there's probably something wrong. If I have an HVAC pump or a thermostat that's trying to present a username, there may be something wrong with that unless it's configured specifically for that way. And that comes back to the baselining piece and the onboarding piece to make sure that they're onboarded so that they consistently present themselves to the network. Now, I want to understand who is on what device, in what location, because it does still kind of come back to that first slide and that first scenario that I set out, is what's out there? What should it be communicating with? How should it interact? Should a user be interacting with this device? Should this device be interacting with only its management station, et cetera? But I'm going to want to understand that piece and where it's located before I move on to the next step of trying to enforce it, because if I prevent it from getting the access that it needs to fulfill the business need, oh, there's going to be a lot of screaming, almost guaranteed. Now, how do I understand how these devices interact across the network and interact with one another? Well, I utilize NetFlow. And unlike some of our competitors, we'll advocate for NetFlow all the way down to the access layer. Now, many of our competitors will say, hey, you only need it at the core layer. Well, that's fantastic. If you're trying to develop a segmentation strategy that goes back to that domain of interacting with the data center. But as soon as I want to understand how devices interact in the campus and understand how these devices either peer-to-peer interact or interact with management stations that may sit at the local campus, I want to get flows all the way down to port on the same switch. And that's what NetFlow can do. Is within the Cisco switching hardware, we can configure NetFlow to point at StealthWatch Analytics, or Secure Network Analytics as it's now known. And I'll get all this information. Source and destination IP addresses, ports, protocols, bytes, flags, whole 9 yards. And if I have an identity mechanism out there, like utilizing Identity Services Engine, I can ingest that in so that I can pull in not only the host name, but I can start pulling in security group tags. I can pull in identities into this. And now I'll see this user is interacting with this user, not just this IP address or this MAC address interacting with this other IP address in this MAC address. Now we get to the enforcement piece. And this seems to be everybody's favorite piece. Okay, how do I prevent the devices from finally interacting with one another? Well, I'm going to be the first to say you start with what you've been doing already. We start with your VRFs. with your virtual networks, your VNs. We essentially utilize those mechanisms to say, I can still break out these devices into the logical segmentation or the logical segments that I've been creating since I founded my network back in God only knows when. At some point, though, I am wanting to get to some sort of microsegmentation and prevent my printers from interacting with one another or prevent my users from interacting with one another. How do I do that? I typically do that with a security group tag. A security group tag is going to be a 16-bit identifier that you put into the frame that that device is sending out. It is open source. It is supported by competitors such as Palo Alto, Checkpoint, etc., but is supported on all of our switching platforms and gives us the capability that most of our competitors can't, where we can say 2 devices within the same VLAN on adjacent switch ports, we can prevent from communicating with one another, or we can dictate how they communicate with one another, port protocol. So where do I start? Well, if I'm going to start at the campus, we already saw the big box that says, hey, let me start in the trust boundary that's identified by the campus. But where am I going to start in the campus? I'm typically going to start in one of my smallest areas. I'm going to do this in an incremental manner. I'm going to start someplace where I have a small number of endpoints that I can identify so I don't try to boil the ocean. Try to understand how these devices interact with one another, how they interact within the VLAN, across the VLAN, and then outside of the site. Because eventually what I'm going to want to do is then move up a little bit bigger and a little bit bigger, and eventually cover my entire campus area, starting with my smallest sites, moving up through my largest sites. It would be the same thing if I wanted to start in the data center. If I want to implement segmentation in the data center, I'm going to start with a known number of workloads that I understand how they interact, or that they aren't going to be business critical and business impactful if I need to analyze and then apply enforcement techniques in an iterative manner. So I'm going to start with a small pod, move up to a bigger pod, move up to a bigger pod, and my policy enforcement point, I'm going to try to get as close to the endpoint as I possibly can here. How am I going to enforce? Well, we have a number of different ways that we can enforce. As I said, TrustSec, downloadable ACLs. So this really comes down to, do you have a fabric-based network or a non-fabric network? For those working with Catalyst Center, with SDA, typically you're going to use Cisco TrustSec, because what you're essentially doing is setting up your entire network with a fabric, i.e. enabling it to send that 16-bit frame from hop to hop as it traverses across the network. And you're going to say, these groups of endpoints are allowed to interact with these other groups of endpoints in this way, port and protocol. For those who haven't gone down the Catalyst Center direction as of yet, downloadable ACLs and downloadable VLANs are wonderful things. Identity Services Engine has the ability, with an open protocol like Radius, to assign the VLAN to your endpoint. So now, no longer, hey, I've moved this pump, I've moved this thing from one room to another, can you reassign the VLAN on this port? Now you can dynamically push that VLAN and say, this device, because it looks like this on my network and it has this user on it, gets this VLAN right off the bat. And then you can filter those up to a firewall, and you can say those VLANs still interact with the firewall. As you want to get that enforcement mechanism closer down to your access layer, well, now we can use a downloadable ACL and essentially a non-stateful ACL say, this device is allowed to interact with our data center, but it's not allowed to interact with these critical resources outside of the data center or this cloud, etc. DNS filtering. Everybody underestimates the ability for DNS to prevent threats from coming into your network. Just the ability to say, based on these categories of traffic, you are or are not allowed to interact with this external workload, this workload out on the internet. When I spun up my website years ago, I was using Umbrella at home, and I was sitting there going, why can't I reach my website on my home network? And it's because I was using Umbrella. And it saw that the website was less than 24 hours old. So it wasn't allowing me to access a website that was less than 24 hours old, just in case it was a newly moved website with malware on it or newly associated with some sort of cloud provider. And that's what you can do as well, is you can essentially say, I want to prevent new websites that are less than 24 hours old. I want to prevent adult-themed websites, violence. My favorite one is to block government websites from people getting to them when I demonstrate things like this, just to show here's the categories you can and cannot interact with. And then in the data center, we use secure workload. And secure workload does everything that I've described for the campus in essentially one product. Identify the workload, identify how it interacts with one another, and utilize IP tables on both Linux and Windows devices to allow or deny the capability for two workloads to interact with each other, even on the same hypervisor. Now, I mentioned that I've been doing this for going on the better part of 2 decades, 15 years inside of Cisco, working for Cisco services. One big key is you don't have to go about this all on your own. Cisco Services is here to help. We have a full gambit of services that we can help you with. Starting with our advisory services. Our Zero Trust Advisory Service helps you break down your business and helps you understand what organizations within your business interact with each other, what sorts of resources do they typically consume, what sorts of endpoints do they typically put on the network. We start to map that out in essentially like a spider map and say, here's who's out there, here's who owns, manages, and troubleshoots the different workloads, the different types of endpoints, et cetera, on your network. Once we get through that piece, then we can work through plan, design, and implement. And that's essentially what I do on a daily basis, is designing large segmented networks to say, based on our best practices, our lessons learned, the hundreds of customers that I've worked with, the thousands that my colleagues have worked with, how do we do this best for your business to protect your business in the best way possible? And then when it comes to managed services, we also have a managed services team, which a lot of people don't realize. But our managed services team are world-class experts who can work with you to stand up a ServiceNow instance and track all of your change management events, your adds, your deletes, your changes, et cetera. Thank you, everybody, for your time. I very much appreciate it. Please do your session surveys. This presentation's been changed, I think, 3 times in just the past 3 months based on feedback that I got from people in rooms like this. So please, please, please feel free to leave feedback in your session surveys. I'll be here for questions for the next 5 to 10 minutes. Thank you for your time.
All right. Hello, everyone. Thank you all for being here. I hope you are all having a productive day so far and a great start to Cisco Live here in Amsterdam. I'm happy to be here once again presenting here on this stage. Welcome to this session. And before we get started, I want to get a sense of the background of the audience. So please help me out. I want to understand where you're coming from and your interest into cybersecurity. So please raise your hand if you are someone that has a network engineering background and you're here because you want to transition into cybersecurity. Perfect. I see like 60% of the audience is coming from that background. Now raise your hand if you already are very much into cybersecurity. And this is more of a like Cisco cybersecurity kind of session for you, and that's your interest. Okay, I still see maybe like 15%, 20%. All right, perfect. Thank you for that. So my name is Alessio Valdez. I am a TME leader here at Cisco, and like many of you, I come from that networking background. And given the landscape, right, the digital landscape today, we are sometimes motivated, I would say, to learn and go beyond just networking and expand into cybersecurity. So that is going to be the focus of the session for today. So thank you all for being here. Some housekeeping items. We have a Webex space for the session where myself and other members of my team are going to answer any queries, any questions that you may have. We will have this available until the 28th of February. So please join in and start the conversation. For today, the agenda is going to start by myself defining what cybersecurity is, its importance. I will then cover some fundamental topics around cybersecurity. And these are going to be important concepts to know if you want to get into cybersecurity. I will then talk through some common attacks. These are mainly going to be network-based attacks. Me coming from networking, it's easier for me to learn and explain those kind of attacks. I will then talk about the Security Operations Center, what the SOC team is, the responsibilities, as well as some of the tools that the SOC team utilizes to protect the organization. Briefly, I will then talk about the incident response process and the different services that the SOC team provides along that process. I will then conclude the session with some tips for you to continue learning about cybersecurity. So let's start by defining cybersecurity. Cybersecurity is the ongoing effort to protect individuals, organizations, as well as governments from any digital attacks by protecting networks, systems, data from any unauthorized use or harm of all of those resources. Now, this is something that happens at different levels, and it means different for depending on the level that you're looking at this. Starting from the personal or individual level, it means that you need to safeguard your identity, your personal data, your personal devices. At the organizational level, this is a shared responsibility because what you're protecting is the reputation of that organization, the intellectual property in some cases of that organization, and this is a shared effort among everyone that is part of that organization. At the governmental level, this is even more critical because what is at stake here is national security, economic stability, and the well-being and the security, the safety of all those citizens. So it is of utmost importance to keep cybersecurity as something that is top of mind at all these levels, but of course at the governmental level even more. Cybersecurity is a very broad topic, and there is multiple different categories for cybersecurity. I have in this slide like the most common ones and the ones that I want to highlight for this session. Started with network security, which for a lot of us, this is a natural first thing that we touch when it comes to security. And it is all about protecting the network, protecting it from unauthorized access. This is all about the networks, the type of security that you can provide at the edge, those kind of things. We also have application security, which is analyzing the security levels from an application perspective and understand whether or not there are any weaknesses or weak points in an application where we need to apply certain measures. One example would be encryption. All the applications should be encrypted to prevent anyone from eavesdropping and looking at the data that is being used on the applications. Information security, which covers making sure that the information is kept private, that the information is secure, and that the information keeps that data integrity. An example of a measure for information security is encrypting the data when it's in motion, but also when it's being stored. And in addition to that, when it is being stored, create duplicate copies for that information to make sure that there is always a backup of that information. In terms of operational security, this may not be as common, but this is something that when a company or a business has certain processes that are critical for their business and to achieve their business goals, those processes need to be protected in a way that there's always a way to have a backup plan to recover from a cyber attack. The same for disaster recovery. This not only protects protection from cyber attacks, but also protection from natural disasters, and it has to do with risk management. End user education, You may have this in your organization, but every now and then, HR reaches out to the teams to take security training, and it's part of that collaboration against cybersecurity. We all need to be educated and know how to identify suspicious activity and understand how to report any potential incident in the corporate network. Now, I'm going to go through some security concepts that are important for all of you to know, starting with the CIA trade. And no, it is not the CIA that you may be thinking of. It's not that. And that's why we also have the AIC trade. So the CIA trade, it's a fundamental information security concept. And it has 3 components. The first one being confidentiality. And that means that only authorized users can view that sensitive information. We need to take all the necessary precautions and set the processes that are required for allowing only authorized users to view that sensitive information. The second component is going to be integrity. And integrity is around allowing only the authorized users to make changes or modifications to that sensitive information so that it remains with that integrity that is critical. The third one is going to be availability. All the systems that keep that information that is crucial for the organization and for the company, the systems need to be available to the authorized users of that information, that sensitive information. So that is also critical. All the systems and resources need to be available for them to make the necessary operations for everything to continue progressing. Now, I have additional security concepts that are also relevant and important for you to understand if you're getting into cybersecurity, starting with threat, which is any circumstance or event with the potential to cause harm to an asset. And an example of a threat could be malicious software that is targeting workstations, a software that is targeting some of the applications that maybe is trying to exploit a vulnerability, which leads me to vulnerability, which is a weakness that compromises either the security or the functionality of a system. In this case, it could be maybe a weak password that we've set to access some critical system within the organization. Or an example of a vulnerable asset could be a workstation, a computer that is running outdated operating system. That is what is considered a vulnerable asset. Exploit, and this is something that is or happens when a vulnerability is made available publicly. What happens is typically attackers create a tool that allows them to exploit that vulnerability. So you need to act fast. When a vulnerability is disclosed, usually it comes with a software patch or something that allows you to prevent anyone from exploiting that vulnerability. This leads me to risk, which is how likely a particular threat that uses a specific attack will exploit a vulnerability, and that is going to create some compromise in the organization in all the critical assets. So that's what's risk. We have 2 additional and very critical security concepts. The first one is attack surface, and this is the sum of all the security risks that an environment has and that are accessible to an attacker. An attack surface has multiple different categories. This is the people. We could run into some social networking kind of exercises that could lead into an attack. The network is another category of attack surface. Software, as I mentioned, unpatched software could become an attack surface. And the physical, having the security measures to prevent anyone from gaining physical access to the network or to critical system is also an attack surface. An attack vector, this is when there is a method or a path that attackers can use to gain access to the network or to resources. That is what's considered an attack vector. And an example of attack vectors could be devices that are misconfigured, phishing emails, and also some unpatched software. Those could be attack vectors that can be used by attackers to gain access or to compromise the digital infrastructure. Now, what are some common attacks? And again, these are going to be based on networking because that is my background. And I want to start with something that, for a lot of you, is where you started maybe with networking, which is the TCP/IP protocol stack. We all know that when the internet started and when networks became available, the first goal of TCP was to communicate or transfer information from one place to another quickly and reliable. We did not anticipate for the network and the internet to become what it is today. So when it was initially designed, it did not have security in mind. This over time has been like improved and patched, etc. But in general, we have some of the network security risk because of this initial flaw in the design, because we didn't think about security. So it has some weaknesses in its design, and early TCP/IP protocols are insecure, were susceptible to certain things. I have here a list of the most common vulnerabilities and attacks for both IP and ICMP. In this session, we do not have enough time to go through all of them, but the ones that are of note are man-in-the-middle attack, which I will cover in a second, session hijacking, denial of service, and ICMP sweep attacks, which is something that is used to recognize which IP addresses, which hosts are available in a network, and potentially use them as target. There are many things around UDP and TCP where you can utilize some of the flaws in TCP and UDP to perform attacks that literally focus on exhaustion of the resources, flooding the network with TCP SYN floods, flooding the network with UDP packets that are sent to some of the ports, which results in a resource exhaustion attack, which could also lead to denial of service in the network. Now, the one that I want to talk a little bit more in detail is the man-in-the-middle attack. How many of you are familiar with this type of attack or have an idea what it will be? Okay, perfect. So I have just an animation that illustrates what that is. So we have host A that is communicating as it normally would on the network with host B, but we then have host C that somehow gains access into the network and starts to eavesdrop on the communication between host A and host B. At some point, it is able to pretend that it is host A in the eyes of host B, and the other way around with host C. It pretends to be host B in the eyes of host A. And what this could mean, what this could happen with this, it could possibly gain privileged access to a network resource that maybe host A has access to. So by pretending that is host A, it could potentially get into some important resources within the network, and that is never good. So this is an example of man-in-the-middle attack, which we see as one of the common attacks in TCP/IP. Now, the Security Operations Center, which is something critical for protecting an organization, not only the network, but other layers of the components of a digital infrastructure from a company. It's going to play a very critical role, and it is a key element in the overall cybersecurity solution. The SOC team has primary responsibilities, and that is first one, to prevent a security breach. And the second one is going to be in the case of there being a cyber attack, the SOC team is responsible for responding to that threat, to that attack. Now, it requires It could be a big team of analysts, and it requires for them to collaborate with other areas of the organization. At the beginning, I mentioned that this is a shared responsibility, and yes, the SOC is the primary owner of responding to a cyber attack, but they do require to have some collaboration, build a relationship with other departments in order to respond to an incident. So here's a view of the different departments that a SOC team needs to engage with and collaborate with in order to respond to a threat, to an incident. As an example, if the SOC identifies that there is someone gaining access in the network because there was a misconfiguration in a firewall rule, they will initially go and reach out to the NOC team and request for them to make some changes on the firewall rules. They could also ask them to update some of the access policies on the network or on some of the applications. That's one of the examples of a collaboration between the SOC team and the NOC team. Legal, in the case of the company being a company that maybe offers a service publicly, it could be like a cloud service, there may be some legal implications in case of an attack, where they need to collaborate with legal to disclose the vulnerability or details about the attack, so they need to collaborate and consult with the legal team. HR, one of the main things is like user education. As I mentioned, the SOC team may be creating some materials for internal users of the network to get familiarized and understand how they can identify suspicious activity. They also need to be educated on how to report these incidents. In addition to that, they may need to make some internal communications about some changes in the applications because of a cybersecurity attack. So this is how they collaborate across all these different departments. And these are just examples. There could be more and more organizations internally that they need to collaborate with. Now, this is going to be, I think, interesting for a lot of you because I'm going to be talking about the different tools that a SOC team leverages in order to protect the organization. They rely on multiple tools and systems. And the first one is the ITSM kind of tool. This is the IT Service Management tool, which is going to be a workflow of tools that they use to collect and manage incident information. So this could be alerting that they have in place that automatically generates a ticket that the SOC team then evaluates, picks up, evaluates, and determines if this is something that it needs to go up to the next level. It needs to go to the tier 2 SOC analyst for them to further analyze. An example of an ITSM tool that is very popular is ServiceNow. A lot of you probably use it and are very, very familiar with it. But that's one of the tools that the SOC team utilizes. The second one is SIEM, which is one of the tools that is going to be doing that real-time monitoring and analysis of events. They're going to be logged in this tool. And from here, we could start also the triage of an incident, where it will go through the different steps of analyzing the incident, the logs, and determine whether it needs to be escalated further up the chain. An example of this is Splunk, which is now part of Cisco, and I'm sure a lot of you have already used it in many cases. Another tool which is specific to network monitoring for malicious activities, it's IDS and IPS. We at Cisco, we use Snort. We use it in some of our security appliances like Meraki MX, as well as other Cisco Catalyst devices. So this is the protection that you have at the network level that is continuously monitoring and looking for any threats or suspicious activity on the network. There are other third-party IDS and IPS engines, but this is an example that I think it's appropriate for this session. Vulnerability scanner. This is a tool that is used to assess whether there is a vulnerability on some of the software that is running on computers, on the network. And what it scans for is weaknesses on the network or on the applications. A very popular tool for this is Nmap. This is a third-party tool that is very popular. I think it's free software that you can use and play with. The third one, or the last one, is going to be threat intelligence, which is going to be a very, very key component of the overall strategy of a SOC team, because this is how they stay up to date in terms of new threats, new vulnerabilities, new actions that they need to take to protect the organization. There are multiple vendors and multiple sources of threat intelligence, and I would say that it is more common than not to have multiple sources of threat intelligence. You cannot rely only on one if you want to be like fully secure. You need to diversify the different sources of your threat intelligence. Of course, an example that we have is Cisco Talos, which is what we at Cisco utilize and leverage. But there are many, many other sources of threat intelligence that I think it's important for all of you to be familiar with. Now, the last bit in terms of content is the incident response process, which is something that it can be very complex. It can be very long. It could be also tedious, but it is in place for a reason, right? If you want to keep your organization secure, you need to adhere to all these processes. This is a process that is set by the SANS Institute, which is an institute that is a leader for cybersecurity certifications, and it's a 6-step plan for the response of incidents. It is widely used in cybersecurity. Here are the different steps, and I'll go over each of them in a little bit of detail. So the first thing is preparation, and this is when the organization does like an inner evaluation of how they want to set their security posture, what kind of policies do they want to have. That is the first step. They need to do an assessment of risk. They need to have an understanding of what are the assets that are more sensitive for them, and define, okay, we have a number of vulnerabilities that we consider high priority. Let's go ahead and tackle those by upgrading even the devices or the software, patching them so that we reduce that security risk that we have. That is going to be the first step. The second one is identification. This is once you have that security policy in place, there will be SOC team members that will start analyzing whether there is an incident or a potential risk on the network. And if there were to be the case, they will identify them, right? They will identify them, classify the security level, and understand if there are any other actions that need to be taken. This is the process where they also take care of documenting any evidence about those incidents or those risks that you may have, because the next level or the next tier of the SOC team will use that evidence to further analyze the risk, the potential risk, and determine whether they need to take action or not. Containment, this is a phase that happens once there is an identification, they have the evidence, and they do consider it of risk enough for them to take action. They contain it so that it doesn't spread on the network beyond what it already has. So containing it up until that, maybe that part of the network, maybe by disconnecting all the users on the network, containing it there, preventing the spread of that incident. Eradication, this is when you take care of removing all the data that is considered vulnerable, removing all the bots maybe in the network that were found, and making sure that they are completely removed from the network, and that there is no risk that they could, like, maybe over time reappear. There could be like another instance of the same problem. You need to make sure that it is completely eradicated. The last bit is going to be around recovery, which is making sure that all the systems that were impacted after they've been cleaned, you put them back up and running in a normal state. you are sure that they are not going to have a problem again. That's when you go ahead and put them back online and in the normal state. The last thing is going to be the lessons learned. This is doing like a post-mortem. What went wrong? Where did the attack come from? What processes do we need to put in place in order to prevent something like this from happening again? So it's documenting all the evidence, documenting the timeline of the incident, and making sure that you understand that potential threats like this do not happen again. This is all process, and it continues over and over again. A SOC team cannot focus solely on the containment phase. While they are doing the containment and maybe the eradication, there is somebody within the SOC team that is going to be looking at identification, because the attackers, they don't stop, right? So why should the SOC team stop? This is a continuous process, and the services that the SOC team provides along or throughout all of this process are detection, respond, and recover. These are non-stop processes that continue and continue and continue and over again. For today, we are concluding the session. I hope this was informative for all of you. The key takeaways and the things that I want to recommend for all of you are to remember that it is important to learn about the fundamentals for cybersecurity to get started. My recommendation, if you're coming like me from networking, is to start with cybersecurity concepts that are close to the world you're coming from, like network security, because that way the learning curve is going to be not as steep, and maybe it's more fun and it's easier for you to start with that. And the other thing to keep in mind is that cybersecurity continues to evolve, continues to change, so you need to stay up to date with cybersecurity. It's not easy, and I would say it's very similar in networking. It continues to evolve. The difference here is that with cybersecurity, there are more things that are at risk, and if there were to happen a cyber attack or something, it's hard to recover from. So it is important. And remember to fill out the session if you want to be in for a t-shirt, nice t-shirt from Amsterdam. And I have some recommendations for you on sessions that you may want to sign up for if you want to continue learning about cybersecurity during Cisco Live. There's a couple of sessions on Thursday that I would recommend, and there's one tomorrow at 5 p.m. Two of them are Cisco U session, and one of them is more of a breakout security session, which is going to be more in-depth and more with a technical focus. So with that, I want to thank you all for your time and for your attention. I'm happy to have been able to deliver this session. Thank you.
Okay, wonderful. Hi, everyone. Good evening. So great to see so many people out here on a Monday evening, day one of Cisco Live. I hope it's been a lot of learning, a lot of fun, and you're looking forward to 4 more days of this. Great to see so many people in the room, and also, as my teacher used to call it, outstanding students. A lot of people out there as well listening into this session. So great to see everyone here. So welcome to this session on becoming a network doctor using packet captures and Wireshark. So quick question to see a raise of hands. How many of you are an actual real doctor? Anyone? No? No one? Okay. Hopefully, sorry? Doctor in networking. Yeah, that's what I was going to say. Is hopefully this is the beginning of your journey towards becoming a doctor in networking using this tool called Wireshark and packet captures. Okay, this one probably will see a lot more hand raises. How many of you have been a network engineer in the past? Everyone, pretty much. Amazing. So have I.
Now, no offense to people that manage applications or databases, but anytime there is a problem in the network, right, something doesn't work, a user has a problem accessing an application, database can't talk to each other, an application is slow, oftentimes the finger point first to the network. Now, I come from TAC. I've been a TAC engineer for 15 years. I'm a principal engineer in the CX engineering group right now. But during my tenure in TAC, and especially security TAC supporting firewalls, the fingers always used to point at firewalls, because guess what? Firewalls are designed to drop traffic. So if something's broken, it probably has to be the firewall. And for me, among a lot of different tools, one of the things that you really want to do when you're troubleshooting network problems, especially large networks, is isolate the problem to a specific point in the network. Right? You want to know exactly where the problem is that the user is reporting. And a great tool to get started with doing that is oftentimes packet captures. And knowing how well to use packet captures using tools such as Wireshark is a great arsenal, great weapon in your arsenal in order to getting to the root cause much faster, right? Much more efficiently. So that's why I like to say that Wireshark is a network engineer's best friend, but I don't think this does justice. I presented this session at Cisco Live in Melbourne about 3 months ago, and I saw this hat by one of the vendors that said PCAP or it didn't happen, which I think is a more apt statement, right? So I think this is even better than that. So I don't know if they're giving it out here in this Cisco Live, but if you do run across this, or maybe you want to print your own hat, this is a great saying to have. So really quickly, we're not going to use a lot of slides today. This is the session agenda for today. Everything is going to be a live demonstration, and if something doesn't work, you know that it's live, and also we'll use packet captures to hopefully try and troubleshoot why it doesn't work. It'll be a live demonstration of that. So at the same time, I want to make sure it's interactive. So while I have a set of things that I would like to get through, but I'm not really married to it as such. So if you would like to see something special, something different, something unique, you have a question at any point of time, please do feel free to raise your hands, ask your question, and we'll try and have that conversation at that time. So how many of you have used Wireshark? Have it installed on your workstations? Yes? Most of you do? OK, awesome. So I thought I'll have this slide up there for those that don't, but looks like no one here is belonging to that category, so it's out here. So installing Wireshark. So since you all have already familiarity with Wireshark, I don't need to necessarily go through the details of this UI. Apologies if it's a bit small. This is just the default font that Wireshark comes with. I can't really zoom into this, is what I found out. But this is the default view that you're used to Wireshark. On the very top over here, you have the ability to filter and a set of quick menu options. When it comes to working with Wireshark, you have two options. Either you can open an existing packet capture file, or you have the ability to actually run a live capture on one or more network interfaces that are on your system at this point of time. So I'm going to start a packet capture on the wireless interface, obviously because I'm connected to the wireless network, by just double-clicking that. And the moment I double-click, and this one I can zoom into, this is what you're used to seeing, a bunch of different packets that are shown in the capture. As they are being captured live. We're using IPv6 over here, so kudos to that. So we'll just stop the capture here and get you a little bit familiar. I'm not going to spend a lot of time on the UI itself, but start really going to the tips and tricks of how you can actually use the UI really effectively. How many of you see something different on the screen that you haven't seen before? Is there anything different in the layout, the overall layout? What is it? The bottom right? Yeah, is that the same thing you're pointing to? The bottom right? That's really cool, right? If you wondered what that is, I also didn't know much about it. Very recently is when I found that out. It's something called packet layout, right? So one of the things you can do, so by default, when you go to Wireshark preferences and layout, by default, what you see is packet bytes. This is probably what you're used to seeing, which is like the actual bits and bytes and the ASCII representation of the same thing. I feel Wireshark is a great learning tool. I've used that a lot to learn about protocols, how they actually look, what are the different fields in the headers, how does TCP work, how does UDP work, how does NetFlow work, so on and so forth. But this is a great visual aid if you're especially learning a new protocol, is using something called packet diagram. So what packet diagram gives you is, for each of the packets, the actual set of headers and where they belong in the actual header itself. What comes before, what comes after, where in the context of the overall headers does this belong. So if I were to pick any packet, that's over here. Let's say I pick this, and I want to see something about TLS, right? If I click on, OK, TLS is probably a bad example here because there's not many fields here. So I'm just going to use TCP. If I wanted to understand where this particular field is in the header, you can see immediately that that gets highlighted. So within the context of what you're doing, if you're especially learning something new with Wireshark, I think this is a great new addition. This has been available since Wireshark version 3, but not really well advertised. So this is me doing an advertising job for Wireshark. So if you haven't used this, there you go. This is something that you can use if you're looking to learn something new with Wireshark. So there are also a lot of customization possibilities available for you when you're using with Wireshark. It's a great visual tool. So more visually, make things stand out for yourself. You can actually be more efficient when you're using, when you're analyzing packet captures with Wireshark. So one of the things that you can do, and this is especially true for me. I don't know if it's true for you. One of the problems that I really hate troubleshooting are performance problems. A user comes and says something is slow. It used to work at a certain speed. I used to be able to download a file in 15 seconds. Now it takes me 20 seconds. Those are really perceptive problems, right? Perceptions are difficult to measure. And those are really the dreadful kind of problems. But it also gives you pleasure when you start actually figuring out what's going wrong. So it's a love-hate relationship I have with performance problems. To start with, I don't like it. But once you start actually working on it and you figure out what's going wrong, you tend to like them a lot, right? So when it comes to troubleshooting performance problems, oftentimes with TCP, there are specific fields that you're paying attention to, right? So you want to see, for example, the sequence number and the acknowledgement number, or something like the window size, right? How many bytes can the receiver receive at this point of time? How many bytes are left in the receive window at this point of time? What you can do is go through packet by packet, as I can over here, and look at the actual window. So in the first TCP segment, I can see the window size is 426. The next one, 2044. The next one is obviously not TCP, so we'll go to the next one over here. It says 2048. Now, this is a bit cumbersome, right? You actually have to click each packet, select each of them, expand the headers in the bottom, and see where the window size is. One of the things you can do is create a dedicated column out of this, so you can see this within the context of the packet listing. And the beauty of Wireshark is if you're thinking of doing something, you don't actually have to go looking for how to do it. Oftentimes, it's just available directly with the right click. So over here, if I wanted to add the window size as a column, I just right-click and say Apply as column. And immediately, it shows up over here. So now, if I'm really interested in troubleshooting a TCP problem, I'm interested in the window size of the receiver and see how it's changing over time, I can now quickly glance through this by just scrolling, as opposed to having to look at the TCP header. Great way of actually using the UI to make your lives easier. One other thing that probably is catching your eye over here are some of these packets are colored differently. Right? And if you really used Wireshark enough, you know that this color means something's wrong, right? Danger. You need to pay attention. This is actually a problem. And if you take a look at what this is, you will see why it's calling that out over here in the analysis. Yeah, it's giving you some details as to why it thinks it's wrong. So it's something to do with maybe a retransmission or something like that. Anyway, so what are these? How are certain packets in the packet listing colored differently? This is through a feature that's available to Wireshark called coloring rules. And you can create your own coloring rules if you wanted to. So let's take a look at how you can do that. So you go into View and Coloring Rules. And what you can see here is the default set of coloring rules that the system already comes with. And obviously, the danger ones that I just spoke about are the ones at the top. If you're used to access lists on routers or firewalls, these coloring rules work the same way. It's the first match that works. So the moment you match a coloring rule, then the packet gets colored that way on Wireshark's listing. So you can create your own custom coloring rules as well. So I'm going to create one over here. I am going to name it TCP 8899. For context, you will see why I'm calling it this. And I'm going to specify a specific filter to use for the coloring rule. We'll talk about filtering in a bit. But the filter I've used here, it's called tcp.port equal to 8899. Okay? And you can specify the colors that you want to use. I'll just set it a unique different color. And I don't know. So foreground is this, background is this. And I will move this in order slightly below. So I need to say OK. And drag it down, let's say, somewhere over here. Right? I want to see it, let's say, in this order. So I've set this over here. So this is a great way of creating coloring rules. Again, a great visual tool, right? A picture often communicates 1,000 words. If you are in, let's say, a security role, a security operations role, you might want to create coloring rules for specific domains that you don't want to see in your network. Create a regular expression out of that, so that if a packet has that regular expression, a domain that's a malicious domain, then you know that there's something wrong. Or if you are managing a network that has a production site and a DR site, you might want to create a different coloring rule for DR, disaster recovery, because that's probably something that you don't want to see in a packet capture, right? So you can create different coloring rules so that it immediately stands out, and you don't have to actually pay very close attention to what's actually in the packet. Again, this is available within context. Like I said, right-click is your best friend when it comes to packet captures. So if you wanted to create a coloring rule using a specific filter, like a port, again, right-click, colorize with filter, and you can just create this from here. Right? So everything is available with right-click. If you think of something, it's generally available there. Cool. So you saw a few tips and tricks, hopefully, of how you can customize the UI to be more efficient when it comes to working with packet captures. Now, let's look at a little bit more of some of the statistics that are available in packet captures. So oftentimes, when you're troubleshooting problems, this packet PCAP that I'm showing you here, Wireshark capture, the font's really small. It says it has 184 packets in the bottom over here, which is not big, right? It's actually, honestly, really small. But if you're troubleshooting a problem with a large network, especially performance kind of problems, you would get PCAP files which have tens of thousands of packets, right? Lots of packets that come along with them. Now, how do you find the needle in the haystack? The particular item of interest that you're looking for in that packet capture that has several gigabytes worth of traffic captured in it. So there are several statistics that Wireshark ships with by default. What you see here are 2 or 3 sections. The first section over there are general purpose statistics that are available for any packet capture, right, about the PCAP file itself. And in the bottom, the second middle section that you see here are protocol-specific statistics that are available with Wireshark. For example, for HTTP, for TCP, for DHCP, so on and so forth, right? Different kinds of protocols that have statistics as well. So we're going to start with some general purpose statistics, okay? So let's use the same PCAP file itself, and I'm going to look at something called conversations to start with. And this is oftentimes what I like to use when I'm working with packet captures, especially larger ones, because I need to find the particular conversation of interest for the specific problem that I'm troubleshooting. How do I get to that rapidly, right? So this conversations filter basically gives you different conversations between unique endpoints A and B at different headers of the TCP IP layer. So at layer 2, Ethernet layer, these are the MAC addresses with unique conversations. This is at the IPv4 layer. This is at the IPv6 layer. Obviously, we're using a lot of IPv6 in Cisco Live now. This is at layer 4, at TCP, and at UDP. And if, let's say, I was interested in a particular IPv6 address, right, then I might narrow down on that immediately over here. Let's say this was one of interest for me for a particular problem that I was troubleshooting. I know this is where it belongs. And what I can do immediately is apply the selected one as filter. Again, all within context. I don't need to go and figure out how to do what filter to use. I can apply this selected one as a filter. So I'm going to do that and filter on something called the stream ID. And immediately in the background, you see the PCAP file that I had got filtered down for that specific TCP conversation of interest for me. So even if you had thousands of conversations, you can actually sort that down and see which particular port, which particular IP address you're interested in, and get to that immediately. Now, talking about filtering itself is an art, I'd like to say. Filtering is possible for basically any protocol header field in the packet. You can filter down using any specific field. Some of them will be wider, like the TCP ports and IP addresses will show you a lot of information. You can also get very granular and say HTTP filters on a specific request method, such as get or post, right? Or you could use DHCP messages, such as discover, offer, acknowledgement, whatever those may be. So you get filters basically for every specific protocol header field possible with Wireshark. Again, filtering is possible within context. So I showed you a filter using something called a stream ID or a stream index. Okay? So where do you find that over here? So if you see here in the TCP headers, there's something called as TCP stream index. And if you pay very close attention, most of the fields here are not inside brackets, whereas there are some fields that are inside brackets, such as stream index 11 is inside square brackets. This conversation completeness is inside square brackets. TCP segment length is inside square brackets. So there are a bunch of things that are inside square brackets and a bunch of things that are not. So those that are inside square brackets are things that are added by Wireshark as metadata in order to aid you in your analysis with packet captures. And the stream index is one such thing. So every unique TCP conversation has an incremental number assigned to it, starting from 0, 1, 2, 3, so on and so forth. And you can actually filter using these metadata fields as well. So you don't have to actually say TCP.port equal to this, TCP.IP or IP.address equal to this, so on and so forth. You can use some of this custom metadata available. Again, filtering the bar over here on top, again, the font's very small, but you can just start typing your filter up there, and it'll essentially try to autocomplete or give you suggestions on how to use filtering. So let's say you're interested in packets that have the TCP push flag set. The flag push is set in the TCP header. So what you can do is tcp.flags.push. You can see it automatically gives me the suggestion, and I can say is equal to 1. And now I automatically get a bunch of segments, TCP segments, that have the TCP push flag set. As you can see here from the flags, I can do that. So immediately, right off the bat, it may be difficult to understand how to do filtering. But the thing is, once you start using it, you'll get more familiar with it. And again, filtering is available within context as well. Right? So I'll always right-click. If I wanted to do this based on the push flag, right-click, apply as filter selected, and it does the same thing. tcp.flags.push equal to true. So filtering is a great tool, again, combined with statistics in order to get you to the specific point of interest in the packet capture that you're interested in. So again, there are a lot of different statistics available for different kinds of protocols as well, HTTP, TCP, so on and so forth. I will show some of this using more of a real-life, simulated real-life example that I will bring up just in a little while. OK, so earlier I mentioned that one of the kind of problems that I often dread, right, I don't like to begin with, are performance problems. Right? So what we're going to do is introduce a performance problem and see how we might be able to use some of the tips and tricks here in order to troubleshoot such a problem, while also showing you some advanced capabilities. So I have this web service running. This is running basically on AWS. Don't try to hack into it. I know there was a security ethical hacking kind of session earlier. There's nothing fancy on this. It's just a simple EC2 instance with just this file and an image hosted on it. So here's a sample web server that I'm running. I'm just going to refresh this to make sure that it's still up. Yeah, it's up. And I have a file available to download over here. Right, so I'm just going to try and download this file. And let's see. Yeah. So you'll see the speed will saturate around a few megabytes per second, 5, 6, 7, not really fast, but OK, it's increasing now, 12, 13, which is not bad. But I'm downloading a file. It's a pretty big file, right? 10 gigabytes of file that I'm downloading. Like I said, users will come and complain and say, my file download was slow. Now what I'm going to do is introduce some artificial slowness to see how that looks. So here's my actual web server where this thing is running. And let's see. So what I'm going to do is basically introduce a drop, basically a 25% packet drop. OK? So there's a traffic control utility that's available on Linux by default. You can use that to do different kinds of things. What I'm doing here essentially is introducing a 25% packet drop. And if you look at the speeds now, yeah, it's down to 1 megabytes per second. It's probably going to go down even further to a few kilobytes per second, which is natural. I mean, TCP as a protocol is susceptible to drops, but it can recover. Right? So it will still continue to download this instead of there being drops, 1 in 4 packets being dropped. But obviously, the speeds are going to be slow. Now, let's go ahead and remove that drop again. And now, hopefully, you should see the speed pick up. Some of you are trying to get a screenshot, a photo of this. I'll keep that open. So you can do that. And now you see the speeds picking up gradually. It's back up to 1 megabyte per second, and then it's going to go on and go on and go on. A user might see the same symptom. It's not really unrealistic for them to see a similar symptom. They might say, a file download started at a certain speed, then it dropped, and then it picked back up again. It wasn't the case yesterday, or it was working fine earlier. I want to understand what's actually going wrong. Can you help me troubleshoot this? Right? OK, let's do one thing. I know I forgot to start a new capture while I was doing this. So we'll just do this again by starting a new capture. So let's begin a new packet capture and try the whole thing again. Right? So we'll go here. We'll download the file. Let it start downloading. Let it go up to speed to 8, 10, 12 megabytes per second. Yeah, come over here. Introduce a drop. Go back. See the speeds drop down. Let's let it go down to a few kilobytes per second. Let it suffer a bit. Yeah. So now it's going down. Now I'll just remove the drop again. OK? And now it should pick back up in a bit. And all this while, I'm capturing these packets. Do you see something different here, right, with packet captures? This was the coloring rule that we created earlier. If you noticed, pay close attention to the web URL. This is listening on port 8899. This was the coloring rule that I created, right? And this is how it obviously starts coloring those packets automatically. So I'm just going to stop this PCAP at this time. I'm also going to stop the file download. Yeah? All right. Not a great color, to be honest. It hurts my eyes a little bit, probably hurts your eyes as well. But I just wanted to show you how coloring rules make it stand out, right? So now immediately, I know where a particular packet is. If I was interested in TCP.port 8899, and if I had a coloring rule, now I know where to pay attention to, because it's right here on my face. Right? I cannot miss this based on just the coloring rule. So I'm going to remove that, because it's not a great color to have. Let's select this and delete it and say OK. So that's gone. Cool. Now let's come back to how we might troubleshoot it. So this time around, if you see, the packet capture has about 200,000 packets captured, much larger than what we had earlier. And now if you're trying to find that particular conversation, it's going to be difficult for you to do. Let's try it with filtering. Right? Let's just say TCP.port equal to 8899. Yeah, it's going to filter, and I see something over here. This may be of interest. This may not be of interest. I don't know. What I'm going to do is start with the conversation filter, the tab that I showed you earlier. So I go into statistics and conversations, and I'm going to look at TCP because I know the port of the web server. It was 8899. I'm going to sort this in order, and you can see there are two conversations of 8899. Okay? There's one conversation here. There's another conversation here. I know the font might be a little bit difficult again. I can't zoom in. But which one do you think should be of interest based on these two? The first one or the second one? The first one, yeah. The first one especially because there's more packets. You see 200,000 packets against that. So immediately you're able to get to the particular conversation of interest. This is how it's beneficial. Even if you had 10, you would know which one to pay attention to. So I'm going to apply the same filter I did previously. Apply as filter. And there's a little beetle that just fell from nowhere. Selected and filter on stream ID. Okay? And if I go back, TCP.stream equal to 7. So this is a specific TCP conversation of interest for me. Okay? Now what do? User said there was slowness. How can you confirm that something actually was slow? The user said something was fast, it became slow, then it became fast again. You don't know what fast means. You don't know what slow means. Again, if you go into the statistics pane, one of the things that's available over here is called I/O graphs, input-output graphs. Okay? So I'm just going to see what it does by default. So I'm just going to plot an I/O graph. And if you see here, I'll just remove these two. I'm not interested. It's created automatically a line graph based on the specific display filter I had earlier, TCP.stream EQ7. I didn't do anything magical here. It created it by itself, assigned it a specific color. And what it's plotting essentially is on the y-axis, the number of packets every second. And on the x-axis is obviously time, increasing from when it first saw the first packet for this packet capture. So you can here immediately see, obviously the number of packets per second was higher. Then it fell down a little bit, quite a bit, not a little bit. And then it started going up again until we stopped the packet capture. You're probably not interested in packets per second. You're probably interested in bytes. Let's change it over here. So instead of packets, I came to this drop-down and selected bytes and click somewhere else. Now it changed it to bytes. And if you see here again, it's actually quite accurate, right? It was about 15, 20 megabytes per second to begin with. Then it fell down to a few kilobytes per second. Then it started picking up again. So now you know exactly what the user saw. When they said it was fast, then it became slow, then it became fast again. You know exactly the kind of speeds that they were seeing. You can also change the granularity if you're interested in. Right now, I think it's by default every 1 second. You can change that to every 1 millisecond. I'm just trying to see where that is. Yeah, anyway. The x-axis should have that, but I can't see it right now. Anyway. Yeah, this one. Sorry, my mistake. Yes, I wasn't paying attention. So here. So right now, it's every 1 second. You probably want to get more granular. 1 second is probably too much. So you could say 1 millisecond over here. And you can see sort of the similar behavior, right, of the number of bytes and number of packets. Great. So now you've confirmed what the user problem was. How do you actually troubleshoot what was the problem? How do you know what went wrong? So over here, I'm going to show you one of my favorite tools that I often intend to use with performance problems is something called TCP graphs. Okay? So if you come down into the protocol-specific section of statistics, you'll see a bunch of different TCP-specific graphs that are available. The one that I tend to like is called TCP trace. Okay? So I'm just going to select that, wait for it to plot the graph. And this is what it plots. And it looks a little bit weird. If you're not used to seeing this graph before, it just looks like, a slope, a slide, and then, a plateau on top, and then you're not really sure what's happening. One thing you need to be careful about is the direction. When it comes to TCP trace graphs, the direction of plotting the graph is critical. If it's a file download that you're interested in, the default direction will work. You will see data over here. If it's a file upload, you should switch direction using the button on the bottom right that you see over there. So if I switch direction right now, you will see a flat line, basically telling you that there's no file upload happening. There's no real data flowing from the client to the server. It's really from the server to the client. So I'm just going to switch the direction back. So you need to be careful of that, depending on the kind of problem that you're troubleshooting. Now, what the TCP trace graph actually plots, and if you notice, I'm just going to zoom in a bit to zoom in. And let's do this. You'll see there are two lines over here in this graph, right next to each other. So it's actually plotting both the sequence number and the acknowledgement number of each TCP segment over time. And the difference between the two essentially is your receive window, right? How many bytes are in flight that have not been acknowledged at any point of time is basically giving you an idea of the receive window. What you typically want to see with TCP trace graph is a linear line, right? It will probably start to increase exponentially, as you saw at the bottom to begin with over here, right? So it started growing exponentially, but at some point it essentially became a linear slope, right? And the more steep the slope, basically the faster the rate of data transfer is. But if you start seeing it actually changing the inclination, over here it's probably a bit too dramatic because I introduced a 25% packet loss. You won't see that generally in a network. But if you see the gradient changing a little bit, or if you see any of these small little divots that you see here, let's zoom into this. Let me zoom here. If you see any of these small little divots that you see, let me zoom out, drag. Right, so you see any of these things, these small little red lines over here, basically these are representations of duplicate acknowledgements. So anytime an acknowledgement is sent a second time, you know that something is wrong. That means some packet or some TCP segment was lost in the middle. And if you're interested in what happened right there, all you need to do is click over here, and in the background, you're getting to that particular packet in the packet capture. So now I know exactly where the problem happened and what's happening. So I see a bunch of duplicate acknowledgements. And if I scroll up, I'll probably see a bunch of out-of-order packets, bunch of TCP retransmissions, so on and so forth. So this is a great way for you to actually get to the actual specific point where the problem happened. Like I said, this TCP graph was a bit too dramatic in the change of gradient. It was linear and then it became flat. You'll see a small change in most cases, right? A few degrees, and you know where to focus immediately. One last tool that I want to leave you with in the last minute is doing something called remote captures. What I'm going to show you is the web server, right? This is the web server I am, and this is the desktop-less environment, right? With Wireshark, oftentimes you need 2 packet captures in order to compare and see where was this drop actually introduced, right? I see drops on the client side, but what about on the server side? Or what about somewhere in the network? You need to be able to compare that. So this is a desktop-less environment. If you wanted to do packet captures on the server, you would probably run something like TCP dump, and then download the packet capture and then open it up locally. A bit cumbersome, but probably something that you all are used to already. Great news is you don't need to do that anymore with Wireshark, because Wireshark has something called remote packet capturing. So if you go into the settings menu, like I clicked over here, you'll see a bunch of different remote packet capture options available over here, including Cisco remote capture using embedded packet capturing on iOS devices. What I'm going to do basically is something called SSH capture. So I'm giving it the remote host to connect to over SSH, which is my EC2 instance where the web service is running. I'm telling it how to authenticate using a username and a private key. And I'm telling it how to run captures, on which interface to run and what filters to use, right? So I'm just going to start the capture now, continue without saving, remove the filter, and I'll just access the website again. Yeah, and if I go here, if you see attention now, everything is v4. It's not v6 anymore. That is an immediate giveaway for you that I wasn't lying. This capture is running locally on the server. I did not have to SSH into the server, run TCP dump, download the packet capture, and run. All of the magic happened automatically. And this is, like I said, also supported with iOS devices using embedded packet capturing. So if you're looking to do remote captures, know that there is a capability for you to do that if you have access to the remote instance. If you don't have access, obviously it can't do it. Cool, so with that, we come to the end. Hopefully there was some interesting tips and tricks for you in this session that you can take back. Again, this was recorded on YouTube. You can always go back to this session and take a look at it. I also have the slides up on GitHub. You can scan the QR code or visit this link and download the slides. And feel free to reach out to me at any point if you have any questions. But thank you all again for your time this evening. It was great. Hopefully, it was great for me, and hopefully it was great for you too. Cheers.
Hello, hello. Can you guys hear me? Okay, all right. Good evening, ladies and gentlemen. I know it's evening and you might be a little tired, but this is very exciting topics about the quantum. My kids know about the quantum from the superhero movies, and when I told him, I'm going to talk about something quantum, and he was like, oh, I know, the Spider-Man and the Hulk, and they were all talking about the quantum realm. But this is not different than, I mean, when I first learned about this entire quantum, it was very fascinating. Fascinating, and also it went on top of my head before I dig deeper into the whole quantum thing, how it can be part of our networking technologies. So my name is Vinay Saini. I'm principal architect with Cisco Services. I help design networks, enterprise, industrial IoT, anything on recent technologies like quantum as well as AI infra. This is a very short session, approximately 30 minutes. So in that session, we won't be able to go too deep into this, but I'll make sure that you get at least an idea of what is this quantum technology about, what Cisco is doing about this, and where do we stand in terms of network security there. So this is my role. Primarily, I'm a technologist. I'm also author and inventor and the mentor. Some of the books which I have written. One is the Zero Trust, which is coming shortly. It's available for pre-order on Amazon. The second one is non-technical, and I have 3 copies of this book. We have a short quiz at the end of this session, and I'll be happy to hand over to 3 participants the book. So AI is everywhere. If you go around and look, everybody's talking about the AI. And this happened in the last Cisco Live in the Vegas. And I throw a challenge to AI and say, okay, AI, tell me, I'm an inventor, technologist. What do I look like in the parallel universe? Because we were talking about the quantum realm. And it gave this picture. Right? Yeah, same reaction, my wife. I told, what do you think about this? And she says, AI was hallucinating. I agree, I agree with that. But then, that's the only AI part in these slides. You won't hear anything on the AI. We are going into the quantum realm. So before we go into the quantum, what is the computing, right? It's all about the computing. We all have the computers faster than quantum, our brain. Our brain is a biological computer. It works on a fraction of the power of a quantum computer, or many generations of computers which are coming in the future. We had mechanical in, a few decades back, or I would say like 100 years back, but now everybody's talking about the classical computers. So for this session, anything which is not quantum, for me, that is a classical computer that works on your chips, on transistors. That is a classical computer. So the history of this started with this gentleman, Richard. He was doing some experiment with the quantum physics, and he wanted to simulate something. And then he realized he cannot simulate those states using the classical computers because they can't even understand that. They don't able to have that kind of a permutation and combination. And this guy says, if we want to calculate something on the quantum realm, we need something which is based on the quantum. He gave this idea of calculation based on the quantum physics And if we think about quantum physics, it's about the spin of an electron, angular rotation of a photon. How do you do a calculation of that, right? People are making calculation out of those computers. So that's how today's quantum computer looks like. They're still infants. They're very similar to the classical computers a year back when they were based on the vacuum tube, you know? So large, so huge. Even today we have. Even the fastest quantum computer today cannot break the encryption. And we'll come to that in a while. So what is a quantum computer? Quantum computing is based on the calculation you make based on the quantum physics phenomenon. Something like superposition and entanglement. So it's not a faster version of your classical computer. It's actually a new way of computing. You're computing based on electrons, photons, and artificial atoms, and so many other things. And a common question comes, so if I have a quantum computer, will I throw my laptop? No, I'm not going to throw that laptop, because you are not going to use quantum computer for everything. You're only giving specific part, which is probability based, to the quantum. You still write a code, even today, on your classical computer, and then you offload certain part of that computation to the quantum computers. The fundamental calculation we are doing in the quantum computer is qubit. We have bit in the classical computer, which can be on and off, 0 and 1, based on the voltage 0 or 5 or any voltage, right? But qubit does not depend on very specific states. You can have n number of states between 0 and 1. That is decided by the coefficients, alpha and beta, what you see. So it means that I can have any states between 0 and 1. It only depends on how much degree of 0 and how much degree of 1 there. But then you will ask, how do we make these qubits? These qubits could be made of atoms, photons, ions. And most of the quantum computers, if you look at, including the one from the IBMs, they are based on the superconducting atoms or ions. So fundamentally what they are is, it's very difficult to excite an electron, put it out of the orbit, and keep it in that state for a longer period of a time. Because of that, they said, okay, why can't we get an artificial atom? So what you see here, the two superconducting layers with an insulator behaves very similar to an artificial atom. And what you saw, the picture of the quantum computer earlier, the big cylindrical type of thing, that is to keep that electron or photon in the excited state for a longer period of a time, because they are very cooled boxes. They do not allow any kind of interference going inside the excited state of that matter. But in spite of that, the coherence time is very, very, very low. That's the reason we are still not able to make the quantum computers of very large sizes. But then what is this? This is like an artificial atom, right? Some alien is there, he says, oh wow, humans finally created an artificial atom, right? That's where we are. But then, this is a mathematical representation of the quantum. So if you read about anything on the quantum physics, it's all about the matrix multiplication, but then you have the coefficients alpha and beta. This is known as the bracket notation. I won't go in depth. This is more of a mathematical calculation. If somebody is from university, they will understand better than me. But then fundamentally, that's how we manipulate things and do the calculations on the quantum stuff. Superposition is another thing where how do you put something between 0 and 1, right? So that concept where you put anything between a state of 0 and 1 to some degree of 0, some degree of 1, that is known as superposition state. How do you do that? Based on what kind of a qubit you have. Typically, you will do with very fine lasers, right? You excite or you change the angle in a certain way, and that decides the state of that. What amount of 0, what amount of a 1 you are putting there. So based on what kind of a qubit you are using, you can do that. So it's nothing related to the voltage and all. You know, we are only talking about the lasers and electrons and the photons, and we are doing calculation out of that. And that's the power. In the classical 2-bit computer, you will have only these 4 states. But in the quantum, you can have 2 raised to power n, because I can have any number of states between 0 and 1. Quantum entanglement is a very interesting phenomenon. So if you entangle two qubits, and let's say I entangle them with something called different entanglement. So what it means is, if one qubit is 0, hypothetically, then another will always be 1. If one is 0, then this is 1, this is 1, this is always 0. The beauty is the distance doesn't matter. You can keep them in the same room. You can keep them in different countries. You can keep them on different planets, different galaxy. Einstein even couldn't figure out why this happens, right? But we are making use of that for the networking, for the quantum security, for exchanging the keys, right? The way I understood is, my wife and I, we are quantum entangled, right? So if my wife comes and brings 2 dresses, red or green, she asks me, honey, which one I should put? I say red. Guess which one she will put? Green, right? And distance doesn't matter, even on the phone. If she asks red or green, I say green, okay, good, I will put red one. That's how I understood the quantum entanglement. That's a good thing, right? But then the main problem is this quantum coherence, how long you can maintain that state, right? A lot of research is going into this area, how long you can keep something excited there. Because if you don't keep those things in a certain excited state, how will you do calculation based on that, right? How do I do the gate operations, which is coming next? These are the classical gate operations we all are familiar, right? AND gate, NOT gate, OR gate. Quantum also uses gates called quantum gates, right? This is the entire area of discussion. We can spend hours on that. But then at a high level, in order to create a circuit or do calculations, you need something called quantum gates. You have an identity gates, X gate. H gate is Hadamard gate, which you use commonly for putting something in the superposition. So if you look at any quantum algorithm or equation, you see H gate will always be there. And then if you put multiple H gates or I gates, you can come up with an algorithm, which we're going to talk about later. I like this X gate because you have a NOT gate in the classical, where you put 0, you have 1, 1, 0. But we have a C0 gate here, which is controlled node. So that means I will behave like a normal NOT gate only if my input is 1. And this is very interesting because this is where it puts things in the Bell state, right? The entanglement state of this. I know, I mean, you might be thinking what this guy is talking about, but then this is more about the physics, and this is how the quantum computer works, and this is the base of something which is carrying everything, right? This is an example of a quantum circuit. What you see, H gate, and then a lot of other gates, Y gate, X gate, and at the end, you are doing a measurement. And the thing of the quantum computers is, in the circuit, when you measure anything, in the end, it will collapse to either 0 or 1. Any moment, if anybody wants to measure anything, it collapses to 0 and 1. But whether it will collapse to 0 or 1 is actually the very probabilistic thing. And that's what they are saying, you know, if we have a quantum computer with enough qubits, we could have developed vaccination for COVID in just 3 weeks. Because it will try all the permutation combination and give you which is the most probable, you know, thing which interacts and kills the COVID virus or something. But then at the end state, if you're looking at tomorrow, it will be the quantum internet, where you are entangling something, and then you have quantum switches, and you're transporting thing. Just before that, you know, I was having interesting discussion with a gentleman in my previous session. They were also looking at why don't we transport actual data using the quantum states. And actually, we are doing today with BB84, where we are doing only transferring the keys between the two computers. But then why we are so much worried about, right? I mean, if you search anything on the quantum computers today, the first thing you say, quantum computers are coming. They will break all the encryptions, the internet will be gone, and we will be in what state? Shock state. And there are some predictions that the world will go into recession if somebody tomorrow says they have a quantum computer strong enough which can break encryption. Because everything today runs on the asymmetric keys. Your entire internet is working on the asymmetric keys. Your bank transactions, your certificates, everything is working on that. If somebody can break that, definitely you have a recession. And prediction says you will take at least 1 year to come out of that recession. Not to scare you, but why that is happening? Because today, the entire encryption is based on this fundamental concept. If I have two large prime numbers, I multiply them and use them, you cannot reverse the process and get the two prime numbers. That's the basic fundamental of the encryption. But then, this gentleman, Peter Shor, he came up with a quantum algorithm, right, using the circuit which I showed you earlier, more complex than that. And he came up with something called quantum Fourier transform. And he has demonstrated that he can break that and bring you back the prime numbers. The only problem is we don't have a strong enough quantum computer who can do the reverse of that for a large prime number. But he has shown theoretically it could be done. So we are just waiting how soon we will get that quantum computer strong enough. But then if you really look at, only the asymmetric encryption is impacted because of the quantum computers, right? Because that's how the Peter Shor's algorithm is able to break the security of the asymmetric. So anything on the RSA, Diffie-Hellman, elliptic curve, quantum computers can break. So what about symmetric, right? Symmetric encryption algorithms are considered safer compared to the asymmetric ones, but you can still break them. I think I have a slide on that, how do you break them? But then, symmetric cryptography is still stronger than asymmetric. Usually we don't consider that, right? The problem with symmetric is how do you distribute the symmetric key, right? And most of the solutions, including some of from Cisco, also suggest how you can distribute these symmetric keys in order to safeguard against the quantum attacks. So there is another gentleman, Mr. Grover. He has also proven that you can also break symmetric keys using the quantum. And now you say, okay, symmetric is also broken, asymmetric is also broken. What shall we do, right? But then Grover's algorithm cannot break. It only breaks if your key is of shorter length. So if you have the key size, which is more than 256 bits or more, that still gives you enough resistance against the symmetric key thing. But you still have a problem of how do you distribute the quantum safe symmetric keys, right? And most of the solutions around that, if you look at, they are about distributing the symmetric keys. The mechanism could be anything. So here is a quick, just for the reference. I mean, you can see on the slides later which algorithms are safe, which are not safe. Asymmetric, definitely. No, but something AES which is symmetric, you have to change the key size immediately in case you have the shorter keys there. And then we have this concept of the quantum key distribution. Symmetric keys, how do you distribute? Imagine you have a scenario, you have two routers, router A and router B. What do you mean by symmetric key? I have to input the same key of both the ends. How do I do that? It's not scalable, right? Or even if it's scalable, it's very complicated process. So we have this mechanism of quantum key distribution. So where you have two quantum devices which are entangled. Typically it's done using the photon, and we use the fiber spool between them. And then you generate the same symmetric key on both sides. So it's a little complicated algorithm. You can search on the Google. It's BB84. Using that, I change the photon phase a little bit, and I keep sending the stream. So both sides, there is an intelligence which creates the same symmetric key without actually sending anything on the internet. And the beauty of that is if anybody comes in between and say, oh, I will check what you're going to do, it collapses the state. And there is a nice video on the YouTube where I think somebody in the Europe has tried this. They connected two video conferencing units using this quantum channel, and they deliberately say, okay, can you try to capture the packet? System collapsed and say, oh, somebody's trying to capture thing, right? And that's how the QKD works. But we are talking more in terms of the network security. So in that, you will use quantum key distribution to distribute the symmetric keys. How we do that? That's coming next, right? So there are two ways. How do you secure and how do you create your network? Or how do you enable quantum resistance in your network is you can use the quantum QKD devices. Quantum devices are the separate devices. Cisco don't manufacture them, but there are a lot of vendors. We have partnership with them. So they do the entanglement part and the quantum physics part, and we are the Cisco guys. We say, you take care of all the quantum things, you generate the symmetric keys, and we will just use it in our algorithm, right? So we have a long list of the partners, and if anybody want to try, we do that. But then the NIST itself is coming. NIST realized, right, and from the last 2-3 years, there is an active discussion happening, okay, if asymmetric algorithm itself is so vulnerable against the quantum, we should do about that. So NIST is already recommending few algorithms. Cisco has already implemented that in our SSL algorithms, and we are going to implement very soon with our IPsec, MACsec, and other things. So you don't need anything. Once NIST is there, that should be the end goal. Everything becomes a quantum safe. But we never know. I mean, NIST says something, but then tomorrow some hacker comes and says, I have broke this, right? That's what the scare thing is. Another thing is, how do you transition? By the time PQC comes, there are ways you can still use the PSK or pre-shared key, which is the manual PPK or manual symmetric keys there. So here are some of the easiest thing. If you want to go home now in your hotel and you want to try something, it's still possible, right? How do we do that? So you can simply have a PSK for your IPsec that becomes quantum resistant. If you want a little bit more, the third option, which is the SKS, which is like more of a software-based entropy we generate in our devices and give. And this is based on McLeod's algorithm. Those entropies, not random entropies. So that is considered safe against quantum thing, and you can try that, right? If you want more complicated solution, we support some protocol called SKIP. That SKIP protocol, you can integrate with any QKD vendor. The problem as of today with QKD is the distance, right? So when you're doing entanglement, that entanglement cannot sustain more than few hundred kilometers, right? So, but the last one and the first one you can do, it even works on the virtual routers. If you have a VM, you just download an image. There is a configuration, there is a documentation available on Cisco sites. You configure, and then you have a quantum resistant IPsec. And this is how the SKIP protocol works. So this PPK source, it could be QKD or a software-based entropy or even in the cloud, we don't care. Whichever vendor you are talking, we can export the keys from there and import into our routers. It's an HTTP-based protocol. It's an open thing. If any vendor wants to implement, they can do this. And this is the lab which I was talking about. It will take hardly 15 minutes if you want to try. You know how to configure IPsec. There are some additional commands, and it activates that internal RFC, and you can input the key. And you see here the quantum resistance is enabled. But note, this is point-to-point. It's still not point-to-multipoint. If you want to try, there is a document available. Download the code. It works. Now, quantum safe IPsec is supported on iOS XE. Now, some of you might want MACsec, quantum safe MACsec. That is also supported on iOS XR. Same options. You have the PSK, standard PSK. This is a day one feature. You don't have to do anything. If you have a PSK, symmetric key encryption, and you have a quantum resistance enabled. So what I'm saying, I'm not saying quantum safe. I'm saying it's a resistant. Right? For actual quantum safe, you still have to wait for NIST or use a combination of NIST and QKD. And again, I think we don't have anything on software here. You need actual hardware if you want to do a MACsec, quantum resistant MACsec. So here are some of the NIST specifications on the algorithms which they are recommending. This is the latest one. I have also kept the reference to the document. And they say if you implement these ciphers and use them in your IPsec or SSL or TLS, it will be quantum safe thing. And we have already implemented this in our SSL code, and we are actually working, as I speak, on implementing them on the IPsec and the MACsec. All right, now the question comes, where do we start? The quantum computers, are they there today? No, Vinay, you told it, coherence and 100 other problems. But then the scary part is, when the quantum computers will come. If you talk about the government, you talk about the defense, you talk about the finance, they have this commitment to safeguard information for next 20, 30, 50 years. And the problem is somebody can have a dump of your encrypted packet, super secure IPsec tunnel today, right? After 5 years, quantum computer is there and they will disclose all the secrets. So that's where most of the customers I'm talking to, they are from defense, government, banks. Because they know that these are the specific information we are doing between countries, between banks, and we want to save it for the next 20, 30 years. So they are implementing all these things now. But then you can't use all these mechanisms at all the links. So what we do is we tell customers you have to do evaluations. Number one things, in your security audits, you need to find out how many algorithms are there in your network which are vulnerable against the quantum computers, right? And then you take a call, you upgrade them. You need to have a migration plan. You should have an infosec plan, And then you identify which information is very critical between the two data centers. But even within two data centers, is there an information which leaks after 5 years, it will create a problem, right? Anybody from service provider here? No? So SPs plays a major role, right? We all consume SP service, MPLS, VPNs. So when I talk to the SPs, they say, Vinay, you tell us how do we make money out of this, right? Because when people come to us and ask, you give me a quantum safe MPLS connection, I don't know how to do that. Or quantum safe IPsec, I don't know how to do that, right? So if SPs start offering, it's very easy for any enterprise and you say, okay, upgrade my connection from normal IPsec to quantum safe IPsec, sort of a thing. So the time is now, you have to start looking at the quantum. I was in a conference few days back in Dubai with the government of many countries, and they're taking it very serious, quantum things. So you have to start thinking now. You have to look at what kind of a policies you need to put in order to have the quantum safe solution. So here is a fun part. Now a short quiz, only 4 questions. You can join it using the QR code or go to slido.com, enter this. So this quiz is based on fastest finger first, right answer plus a combination of who gives the answer fast, the top 3 guys. I'll be happy to give the signed copy of my book. I know this is a short session, 30 minutes, so I couldn't go deeper into that. But there is a lot of documentation which is there on the cisco.com. And we also have few breakouts where we go deeper into each of these technologies. We are also working towards having quantum safe VPN. Now VPN, when you talk about, you have point-to-point VPN, you also have a remote access VPN. Some of our customers from the finance, they're asking, how do I have a remote access VPN on the AnyConnect? So we are also working on that. Cool, so we'll take another 30 seconds to let everyone join, and then we'll start the quiz. All right, so here comes the first question. You have 25 seconds. Don't forget, fastest finger first. By the way, Grover is Indian guy, and Peter Shore, I was doing one online course from MIT, and Peter Shore was the lecturer for that. It was amazing what he was talking, but I couldn't understand anything. Okay, 58% got it correct. Ready for the next? Here you go. 10 seconds. That's right, 80% of you got it right. Next one. This should be easy one. Okay, 54% right. And here we have the last one. This is a very important question because if you try to implement and you do an audit, people will ask you, is your solution NIST compliant? Okay, most of you got it right. And here are the winners. Mr. Alexander. Thank you, sir. AVW and Mr. Domingo. All right, so here is a quick summary. We just have a last slide. What should be our state? Stay informed what is happening because this is a very, very dynamic environment. You might see any day people talking about quantum computer is ready. Something like DeepSeek, right? We know what's happening with the AI. So you have to include the quantum safe solutions. You start experimenting. You identify the vendors. You identify the QKD vendors. You identify the different approach. But then a common thing which is happening, most of our customers are doing is evaluation and assessment. SPs are doing even on the RAN side. SPs are even doing the quantum safe interfaces, right? So you need to do assessment, see what are your weakest link, what are the links you want to go first and make them quantum resistant because you can't do, and then do all these trials in your lab and see which solution is also scalable based on your use case. Like SP, they were looking at rolling out it as a service to make money. But for an enterprise, it could be hub and spoke. I don't know what your topology is, or point to point, which solution is seeking. You're seeking, looking after. The future, we don't know. It could be only NIST, or it could be a combination of QKD and the NIST. There is also an ongoing research because we have a distance limitation on the QKD via satellites. Can I do entanglement over the satellite connection? There are a lot of research papers. If you search on the Google, you will find. That's an open area of research. A lot of dynamic things are happening in this area. So keep and watch out. NIST solution is going to come very soon on Cisco IOS XE, IOS XR routers, even with our AnyConnect solutions. Thank you so much. I hope you learned something. And please rate the session if you like, or give me feedback in case you didn't like something. That's also so that I can improve. Thank you so much.